Okay, so last time we studied about the vectors. Now let's begin the next topic, that is motion in a plane. Motion in a plane. Okay, so what's that? So for an example, suppose you have some object which is moving on a surface. Okay, or you can imagine if you throw a ball in space, it will move something like this. Okay, so if you take its trajectory, if you take its path, that path can be contained in a plane. Okay, its path, suppose it looks something like this. Okay, or it is any object which moves something like this. Then suppose this is the starting point of this object. Okay, so what we can do is basically any object is moving on a plane surface, what we can do is we can take its starting position, it is this one. To describe its starting position on the plane surface, what do we need? We need some point in reference to which we can measure its position, right? So that point we'll call it as an origin. Okay, this point is an origin. So this is our object at the beginning it is at this point, let's say A, and it moves like this. It moves on this 2D surface. So then we'll draw an x-axis and y-axis as per our convenience. Okay, so this is our x-axis, this is our y-axis, and then now if we draw a straight line starting from this origin to the position of that object, we call that straight line as position vector of the object. Okay, that straight line is known as what? The position vector of the object. Okay, so as the object moves on this plane, what will happen? Its position vector will change. So when it is here, its position vector will look like this. When the object is here, its position vector will look like this, so on and so forth, right? So now suppose this is the initial position vector, okay, at some time t, and in time delta t, suppose object moves from this point to this point, so what will be its position vector? Then its position vector is something like this. So object has displaced from this point to this point, and if you draw a straight line starting from the initial position to this position, okay, then this straight line is called as the displacement vector. Okay, this straight line is called as what? Displacement vector. And we can measure that displacement vector. How can we measure that? Using the triangle law of vectors addition, right? Okay, so what I can say is, this is suppose the starting position vector, and the object, it moves from here to here like this. So this would be its displacement, right? This would be its displacement in time delta t. So this vector plus this vector is equal to this vector, right? Using triangle law we can say that. So this is, I am denoting this one as r of t plus delta t. Okay, this is position vector at time t plus delta t, and this is r of t, this is position vector at time t, right? So r of t plus delta t is equal to, I can say, this r of t plus the displacement vector, right? And therefore what will be the displacement vector? Just take that initial position vector on other side. So displacement vector is just final position vector minus the initial position vector. Okay, right? This thing is clear? Yes, no? All right, so this is displacement vector. Then what we can do is, so basically this whole idea of motion in a plane in space is that we can resolve this motion, and if it is motion in a plane, we can study it as two independent motions, one along x-axis, one along y-axis, right? So suppose this is your displacement vector. Okay, this one is your displacement vector, right? Delta r bar. Okay, what you can do is you can resolve it along two components, one along x-axis, you call it as delta rx, one along y-axis, you call it as delta ry, right? So this thing can be written as delta r bar is delta rx plus delta ry. Okay, delta rx bar plus delta ry bar, as we studied in the last lecture. Then now how can you write this delta rx bar? So we know that vector can be written as its magnitude multiplied by unit vector in that direction. So delta Rx bar can be written as delta Rx times I cap, and delta Ry bar can be written as delta Ry times j cap, right? I cap is unit vector in x direction, j cap is unit vector in y direction. Okay, then this is how we can write the displacement vector. We have resolved it along two components, one along x axis, one along y axis. So this is simple up to this point, and everything is going to be simple. Okay, there will be nothing difficult. So see, then how can you find out the average velocity? So you have displacement. If you just divide that by the time taken by the particle, okay, to go from initial to final position, so what do you get? You will get the velocity. So displacement vector divided by time will give you velocity vector. Okay, and then you put delta R bar is equal to this thing, delta Rx into I cap, okay, plus delta Ry into j cap. You put that here. So what do you get? Delta Rx divided by delta t into I cap plus delta Ry divided by delta t into j cap. And what is this thing? So you can just say this is the displacement along the x direction divided by time. So this is velocity in x direction. Similarly, what is this thing? This is the displacement along y direction. Okay, delta Ry is displacement along the y direction. So delta Ry divided by time is the velocity in y direction. So you get velocity is equal to Vx into I cap plus Vy into j cap. Okay, that's very, very simple, right? So the velocity can be written as what? Sum of velocities in x direction and velocity in y direction, right? Okay, total velocity or velocity of an object can be resolved into velocity in x direction plus velocity in y direction. Okay, and if we want its magnitude, how do we find the magnitude? So V just equal to, you can say magnitude of V bar, it's just equal to square root of Vx square plus Vy square. This is clear? Yes, no? Everyone? Alright, very good. Then now this is the average velocity, and we know how to go from average to instantaneous velocity, how to find out the instantaneous velocity, right? So what is the instantaneous velocity? The velocity which is calculated in very, very small interval of time, right? That's the instantaneous velocity. So suppose V bar is the instantaneous velocity. By definition, it is what? Limit delta t tends to 0 of the velocity calculated in time interval delta t. And how do you find that? It is delta R bar divided by delta t. Okay, and again you can write delta R bar is equal to what? Delta Rx divided by delta t into I cap plus delta Ry upon delta t into j cap. And then what is this thing? So this is, you can say, its derivative of Rx with respect to time. Okay, this thing can be written as limit delta t tends to 0, delta Rx by delta t is the derivative of Rx with respect to t. Okay, so you can say it is drx by dt, right? Drx by dt. And what is this thing? So this is dry by dt, right? This thing is clear. What's the difference between this case and this case? So there we found the average velocity. Here what is Vx? It is derivative of Rx with respect to time. What is Vy? It's derivative of Ry with respect to time, right? So this thing can be written as, because we have limit delta t tends to 0, this thing is drx by dt multiplied by I cap plus dry by dt multiplied by j cap. Okay, this point is clear? Yes, no? Everyone? Okay, right. So this is just extension of the earlier topic that we saw. Okay, that is in motion in a straight line. When we want average velocity, we just take what? The displacement, total displacement divided by time. When we want instantaneous velocity, what do we need to do? We need to take derivative. Okay, all right. So then similarly we can find out the acceleration of the particle or of the object from time t to t plus delta t. So how do we find acceleration? So see, now here is the important point sorry, important point. So our object is moving like this along this path, right? So at the beginning here at point A, what's the direction of its velocity? So if you take very small displacement, if we consider, let's say, a displacement from here to here, okay, it will be along the path, right? So it is almost a straight line, and if we take very small time interval, then what do we get? Then to find out the displacement, okay, in time interval delta t tends to 0, what do we need to do? We need to draw tangent to the path. Okay, we'll need to draw what? Tangent to the path. So what's the direction of velocity at this point? If I want to say the direction of velocity at point A, then I will have to draw tangent to the path, because at this moment the particle is moving like this. Okay, then it's curving. Okay, its motion, its path is curving, but at this moment it's moving in this direction. Then after little bit of time it curves like this. So if you want to find out its velocity at this point, it will be moving in this direction, okay, for very little time. Then it keeps on curving. Okay, this thing is clear. So to find out velocity at a particular moment, what do we need to do? We need to draw tangent to the path, right? This is clear, everyone? Okay, so what will be the direction of instantaneous velocity? The direction of instantaneous velocity will be along the tangent to the path, right? What will be the direction of average velocity? So if you want to find out the direction of average velocity from this point to this point, it will be along this straight line. Okay, instantaneous velocity at this point and at this point would be different. The direction of average velocity between these 2 points will be directed like this. Okay, the direction will be like this. And if you want instantaneous velocity at this point, it will be along this tangent. At this point it will be along this tangent. Instantaneous velocity at this point will be along this tangent, right? Everyone, this is clear? Okay, so that's just difference between the direction of average velocity, instantaneous velocity. Okay, so then now suppose the particle moves from here to here. Okay, so suppose our particle moves from A to B in time delta t. So now we want to find out the change in velocity. So magnitude, suppose we know the magnitude, and suppose we know the direction. Okay, suppose we know the magnitude, direction will be what? Along the tangent. So at point A it's moving in this direction, let's say with 10 meters per second. Okay, at point B it's moving along this tangent, but here suppose it is some 15 meters per second, right? It can be same, the magnitude can be same or different, right? So suppose we know the magnitude. At point B it's suppose moving in this direction. So how much is change in velocity? So this is initial velocity vector whose size is this much. Okay, you take it, you draw it at point B. This is final velocity vector, means from A to B, motion from A to B. This is the final velocity vector. So what you do is you subtract this initial velocity from the final velocity, and then you get this thing, this much vector. Okay, the difference is this much, this is delta V, right? So this delta V bar is the change in velocity from point A to B. When object moves from A to B, this much is the change in velocity. okay. And therefore now if you want to find out acceleration, what is acceleration? It is change in velocity divided by time. So if you want to find out the direction of acceleration, what will that be? Tell me, what will be the direction of acceleration? It will be in direction of change in velocity, right? Okay, so acceleration of this particle will be directed like this, okay. So now see, what is the acceleration then? Acceleration is velocity at time t plus delta t minus velocity at time t divided by the time, okay, and it is delta v bar divided by delta t, right? So then its direction will be like this, as we discussed. So this is the acceleration. Again, this acceleration can also be resolved, it can also be resolved in two directions, okay, one along x-axis, one along y-axis. So a bar can be written as ax into I cap plus ay into j cap, okay, right. So everything, the displacement, the velocity, acceleration, we can resolve in two components, and we can study those two components separately, independently of each other, okay. So if there is acceleration in y direction, that will not change the velocity in x direction. If there is acceleration in x direction, that will not change the velocity in y direction. This thing is clear, everyone? Right, very good. So now we have our kinematic equations of motion. So for example, you have s bar, it's equal to u bar into t plus half of a into t square, a bar into t square, right. So now if you think about the one dimensional motion, you don't say it is s bar or u bar etc, but if object is moving in two dimensions, then you need to say that this is s bar is equal to u bar into t plus half of a bar into t square. Again, this equation can be broken into two equations. Which two equations? So if object is moving in two dimensions, you will say sx and sy are the displacements in two directions. If object is moving in space, then you can say that sx, sy, sz are displacement in three directions, okay. And how can you write them? So just say that s is equal to ut plus half at square and put the appropriate suffix, okay. So in x direction, what I will say is displacement in x direction is equal to initial velocity in x direction, okay, it's ut. So u will be ux, okay, for x direction. So it is ux into t plus half of ax into t square. This is displacement in x direction, right. In y direction, it will become uy times t plus half of ay times t square, and in z direction, it will become uz times t plus half of az times t square, okay. And now if you want to find out the total displacement, what will that be? So total displacement s bar is equal to what? Sx into I cap plus sy into j cap plus sz into k cap. So this is in three dimensions, okay. And if you want to find out its magnitude, what will be its magnitude? So the magnitude of s bar is equal to what? It is s, and that s is equal to square root of sx square plus sy square plus sz square, okay. Where does this come from? It comes from the resolution, right. Similarly, what is u? U is the magnitude of velocity, and that is equal to square root of ux square plus uy square plus uz square. And what is a? It's the magnitude of acceleration. It is square root of ax square plus ay square plus az square. So this is clear, everyone? Okay, so now let us solve some problems based upon these things. So let's see this problem. The x and y coordinates of particle at any time are x is equal to 5t minus 2t square and y is equal to 10t respectively, where the x and y in meters and t is in seconds. The acceleration of particle at t equal to 2 seconds is. So now tell me, what should we do to find out this acceleration? Yes, this is simple, right? So now x coordinate is given, y coordinate is given. To find out velocity in x direction, what will I do? I will just say that it is dx by dt, change in x with respect to t, right? This is the displacement in x direction versus time divided by time, you can say, but this is instantaneous velocity, okay, because we are taking derivative. So that's equal to d by dt of 5t minus 2t square and take its derivative, so you get velocity. So that is 5 minus derivative of 5t is 5, derivative of this minus 2t square, minus sign you can take outside, 2 you can take outside, derivative of t square is 2t, right? So this is 2 times 2t, that's minus 4t. So 5 minus 4t, this is velocity in x direction. What is the, this is velocity in x direction. What is the acceleration in x direction? So acceleration in x direction is equal to, let's call it ax. Ax is equal to dvx by dt, and that is just equal to d by dt of 5 minus 4t, take its derivative. So what do you get? You get derivative of 5 is 0 and minus 4 you can take outside, so minus 4 multiplied by dt by dt, dt by dt is 1, okay, so that is minus 4 meter per second square. But this is just acceleration in y direction, okay. Now sorry, this is just acceleration in x direction, and we want to find out total acceleration. That will be acceleration in x direction plus y direction. So now let's find out acceleration in y direction. What's that? So you have y is equal to 10t. So what will be Vy? Vy is d by dt of y, right? So that is d by dt of 10t, and therefore, so if you take its derivative, what's that? It is 10 multiplied by dt by dt. So that is just 10. Okay, and then you have acceleration in y direction. Ay is just equal to what? It is just equal to d by dt of Vy. So dVy by dt, and Vy is constant, that's why acceleration would be 0. So Ay is 0. So what does that mean? What will be the net acceleration? Net acceleration is in x direction only, and its magnitude is 4 meter per second squared. Okay, so it's option B, that's it, because acceleration in y direction is 0, right? Okay, good. So now can you solve this in little bit quicker time? Little bit quickly, can you solve? Anyone? Okay, so just remember, whenever you have a t square term, we saw this in last lecture, right? So you have x is equal to 5t minus 2t square. So there will be acceleration if there is at least t square term. Okay, then you have uniform acceleration. If you have t raised to 3 in the equation of displacement or position, you can say, if you have t raised to 3, then you will have time dependent acceleration. So here if you have t square term, then that means you have uniform acceleration. And what to do then? Then you have x equal to, or you can say sx equal to, okay, it is just equal to u times t, or you can say ux times t minus half of, let's say plus half of ax times t square. So if you just compare this, then what do you get? You get ux is equal to 5, and what is ax? Ax is equal to, or half of ax is equal to minus 2. That means ax is equal to minus 4, right? So you got ax. Okay, good. Then what about ay, acceleration in y direction? So this is y is just equal to 10 times t. So you can just compare this thing with what you can say sy is equal to uy times t. Okay, and acceleration is 0 because there is no square term, no square time term in this equation, in the equation of displacement, or you can say the position, right? This thing is clear? Yes, no, right? So this is how you can quickly find out the acceleration. Okay, good. So then now you might say that this is the equation of displacement, this is equation of position. They are not at all different. See, how can I say that? So what is displacement in x direction? It is x minus x0. Okay, and if there is no x0, there is no constant term here, what does that mean? X0 is just equal to 0, right? X0 is just equal to 0. So where is this particle starting from? It is starting from origin, okay, at time t equal to 0, and you can find that also. So what will be x at t equal to 0 from this equation? From this equation, x at t equal to 0, put t equal to 0, you get 0, right? So x0 is just 0, y0 is just 0 if there is no constant term. This thing is clear, everyone? Okay, good. All right, let's see next one. So a particle is moving such that its position coordinates x and y are 2 meter, 3 meter at time t equal to 0, 6 meter, 7 meter at time t equal to 2 seconds, and 13 meter, 14 meters at time t equal to 5 seconds. Average velocity vector from t equal to 0 to t equal to 5 is, so at t equal to 0, these are the coordinates, at t equal to 5, these are the coordinates. So that means this is just extra information, you don't need to think about that, right? What are the coordinates at t equal to 2? Because you want average velocity, okay? So what is average velocity? You can say v bar is equal to vx into I cap plus vy into j cap, okay? So let's say starting position is x naught, y naught. So x naught is equal to what? At t equal to 0, x naught is 2 and y naught is 3, and at time t, x is equal to what? It is 13, y is equal to 14. Okay, so this is at t equal to 0 and this is at t equal to 5, right? So what is Vx? It is x minus x naught divided by delta t, or you can say t minus t naught. And what is Vy? It is y minus y naught divided by t minus t naught, okay, into j cap. That is equal to, this is 13 minus 2 divided by, it's going from 0 to 5, right? 0 seconds to 5 seconds. So time difference is 5. 5 minus 0 means 5. Okay, this thing into I cap plus y minus y naught. So 14 minus 3 divided by 5 into j cap. Okay, so this is 13 minus 2 is 11, 11 by 5. So 11 by 5 into I cap plus again 11 by 5 into j cap. So that is the answer, or 11 by 5 you can take common. So it's option D. Okay. So this is very simple question, right? They have just given one extra piece of information that we don't need to think about. So this is very simple. And then you don't need to write down this formula, then x minus x naught, y minus y naught. You can directly do this, right? You can always directly do this. Okay, so this is clear. Okay, good. This is very basic, right? Does anybody have any doubt in this? Indusha?
No, sir.
Okay,
Clear.
good. Very good. All right, let's see next then. A body is moving with velocity of 30 meters per second towards east. After 10 seconds, its velocity becomes 40 meters per second towards north. The average acceleration of body is, tell me, who will tell me this? Anybody? Body is moving towards east, 30 meters per second. And then, okay, let me ask this question. Body moves towards east, 30 meters per second is the velocity. Then it takes a turn and starts moving towards north, 30 meters per second. Okay, velocity, the magnitude of velocity does not change. Is there any acceleration? Is there any acceleration? Yes, there is an acceleration. Why? It's because of change in direction. Very good. Okay, so that's because of change in direction. Even if the velocity remains constant, direction changes, and that's why there will be acceleration. Okay, so velocity is a vector quantity. You can change velocity by changing its magnitude or its direction, right, or both. Okay, so here both are changing. So initially the body is moving towards east. So let's say that this is our east, west, north, south, and the body is moving towards east initially, like this. And then it starts moving towards north. Okay, like this. So the question is, what is the acceleration? Option C, root 7 meters per second squared, right? Okay, so this is 30 meters per second, or you can say this is v1 initial velocity, or you can say vy, or you can say u. Let's say u bar is equal to 30 meters per second. Okay, this is 40 meters per second. So this is v bar and this is u bar, right? So now you want to find out v bar minus u bar. What will you do? So u bar is directed like this, in this direction. Okay, so let me just draw it in this way. So let's say initial velocity is like this, it's directed like this. So this is my initial velocity vector. This is my u bar. Okay, so if I want to take minus u bar will be directed like this. Okay, and this is my v bar, 40 meters per second. This is my v bar, it's in north direction, this is in east direction, right? So this is minus u bar. Okay, this is minus u bar. I want v bar minus u bar, right? Because what is acceleration? V bar minus u bar divided by time. So we know, using the parallelogram law of vectors addition, this vector plus this vector, v bar plus minus u bar, that is v bar minus u bar, will be directed like this. This will be the resultant. Okay, or you can join it, you can complete the parallelogram like this, and then this will be your resultant, right? So what is this thing? This is my v bar minus u bar, v bar plus minus u bar, that is v bar minus u bar. How much is it? It's equal to, okay, this is the resultant. So magnitude of v bar minus u bar is just equal to what? Square root of u square plus v square. Okay, by parallelogram law, but it is just a rectangle. So that is equal to 30 square plus 40 square. So you can say this is 3 into 10 and this is 4 into 10. So 10 square you can take outside, right? So that is 30 square plus 40 square. 10 square you can take outside, square root of that will be 10, and multiplied by square root of, it's 3 square plus 4 square. That is equal to 10 multiplied by square root of 3 square plus 4 square. 3 square plus 4 square is 9 plus 16, that's 25. So square root of 25 is 5. So v bar minus u bar is equal to, the magnitude of that is equal to 50, right? And therefore what is the acceleration? So acceleration is equal to, if I just want magnitude, it is just magnitude of v minus u. Okay, v bar minus u bar divided by time. So that is 50 divided by time is 10 seconds. Okay, so that is 5 meters per second square. So this is the answer. Right, so this thing is clear. Okay, so your answer was not correct, right, Yamini? What did you do? Solve this way or did something else? Same. Okay, no problem. Then some calculation mistake. All right. So see, this is how you will think about it. Okay, everyone, this is clear? Nikita, Selva Kumar?
Yes, sir.
Okay, good. All right, let's see next one. A particle starts from the origin 0, 0, moves in straight line in xy plane. Its coordinates at latter time are √3, 3. The path of the particle makes with the x-axis an angle of, tell me. Again, this is simple. It moves along a straight line. Okay, it starts from origin. Now I am explaining this, that's why I am drawing the diagrams and all. You will not do all of this. Okay, right? Okay, so particle starts from origin and it moves in a xy plane. So at latter time, you need to imagine all this in your mind, right, while solving. At some latter time, what are its coordinates? So x coordinate is √3 and y coordinate is 3. Okay, so this is suppose √3 and y coordinate is 3. Okay, so draw a straight line. So I can plot this point on the graph, and then this is just a straight line. This is starting point and this is position at some later time, right? So this, its motion makes an angle theta with the x-axis. Okay, what will that be? So this angle theta is equal to, tell me. So you can always say tan of theta is equal to what? It is y2 minus y1 divided by x2 minus x1. Okay, it's option B. Let's check. What is y2? y2 is y position at this time, that's 3. So that's 3 minus 0 divided by x2 is root 3, x1 is what? 0. Okay, so root 3 minus 0. So 3 by root 3. So tan of theta is root 3. So what's the angle? Tan of which angle is root 3?
60 degrees.
60 degrees, right? So it is option B, correct. Okay, so this is clear. Okay, so you don't need to draw the diagram. You will just say tan of theta is equal to y2 minus y1 divided by x2 minus x1, right? Tan of theta is equal to y2 minus y1 divided by x2 minus x1. Okay, so just remember the basics. All right, so from that you can solve it quickly. All right, let's see next one. A bus is moving on a straight road towards north with a uniform speed of 50 kilometers per hour. Okay, by the way, while solving the questions, while trying the numericals, you can draw the diagrams, okay, because it gives you some intuition about the problem. Okay, but then try to think in your mind only, right? Practice thinking in your mind only. So draw diagrams also now, but in final exam you can draw very quick diagrams, but don't be a Picasso. Right? Anyways, this thing is clear. Yes, no? All right, good. Let's see next one. A bus is moving on a straight road towards north with a uniform speed of 50 kilometers per hour. Then it turns left through 90 degrees. Okay, a bus is moving on a straight road towards north with uniform speed of 50 kilometers per hour. Then it turns left through 90 degrees. If speed remains unchanged after turning, the increase in velocity of bus in the turning process is. Okay, so here sometimes students get confused. Now you will not get confused, right? Because you know that the velocity, there is change in velocity even if what? There is no change in the speed. That means speed remains constant but direction changes. Still there is change in velocity. Okay, so initially it is moving towards north by with a speed of 50 kilometers per hour. So like this it's moving initially. It is moving like this. Okay, and then it takes turn towards left. Okay, it takes turn towards left, right? Okay, so then what is the increment in velocity? Tell me. So this is final, this is initial. This is final velocity, this is initial velocity. What will be the change in velocity? Final minus initial, or let's take initial in this direction. The magnitude remains same. So this is initial, means this is u bar. So this is minus u bar and this is v bar. Okay, so what will be direction of v bar minus u bar? It will be directed like this. Okay, so if they ask us about the direction, then we'll need to draw diagram, right? All right, so this is v bar minus u bar. v bar minus u bar, and speed remains constant. So what will be its magnitude? So v bar minus u bar is the increment in velocity. So that is just equal to square root of v square plus u square. Okay, this side square plus this side square. So that is 50 square plus 50 square, or you can say 50 square times 2, and you want to take square root of that. Square root of 50 just 50 square is 50. Square root of root 2 is how much? How much is it?
1.414.
Yeah, 1.414. Okay, so 50 times 1.4. Let's take 1.4 only. So how much is it? 14 5s are 70, right? 70 point something, 70.7 kilometers per hour. That's the answer. Okay, but this is magnitude, right? And yeah, they are asking about the direction also. Tell me what's the direction. This is east, west, north, south. What's the direction? Southwest.
Southwest.
Right. Southwest. Okay, so it is option A. Right. So in this question, diagram was necessary because they are asking about the direction. This is clear, everyone? Okay, good. Let's see next one. When an object is shot from bottom of a long smooth inclined plane kept at an angle of 60 degree with horizontal. Okay, so plane is kept at an angle of 60 degree. It can travel a distance x1 along the plane. Okay, but when the inclination is decreased to 30 degree and same object is shot with the same velocity, it can travel distance x2 distance. Then x1 is to x2 will be. Now you tell me. Okay, so let me explain this. So object is shot at an angle of 60 degree. Okay, so you have first plane which is inclined at an angle of 60 degree like this, and the other one is inclined at an angle of 30 degrees, right? So the object is shot like this up the plane, right? So in first case it travels a distance up to what? x1. So suppose it moves till here. So what will happen here? Its velocity will become 0. Okay. So now see, it's shot in this direction with speed u, you can say. So there will be some acceleration. That's acceleration due to gravity which is acting downwards. Okay. And there will be a component of that acceleration which will oppose this motion. Okay, so this angle is suppose theta. So acceleration due to gravity is acting downwards like this. So this is g. You can resolve it along two components, one along the motion and one perpendicular to motion, right? So one along the motion and perpendicular to motion. So let's do that. So see, I am resolving acceleration due to gravity in two directions. One will be along the motion and one perpendicular to motion. So this angle is theta. This angle will be what? It will be 90 minus theta. Right, this thing is clear. This angle will be 90 minus theta because this is 90 degrees. This is 90 minus theta. So again, this angle is 90 degrees. This is 90 minus theta. So what will this angle be? This is equal to theta. Okay, so this is equal to theta. So now can you tell me the two components, this component and this component, which one will be g cos theta, which one will be g sin theta? So if you remember what we covered in the last lecture, component along the plane would be g cos theta or g sin theta. All right. So see, okay, so you have any vector, suppose you have any vector and it makes some angle theta with x axis, this is y axis, and this vector is, you can say this is anything, this is vector a bar. So you can resolve this a bar along two components. What are those two components? So the component through the angle, yeah, along the theta, it's cos, yeah. So if you are going to this component, right, through the angle, then it is the cos component. If you are going towards the component, starting from vector, to go to the component, if you want to move away from angle, it is the sine component. Okay, so please remember this at least till this NEET. Okay, so component through the angle is cos component, component away from the angle is sine component. So this one would be a cos theta and this one would be a sine theta, right? Similarly, now if this angle is theta, then what will happen? Component through the angle, okay, component through the angle is cos component, so this one will be cos theta and this one will be a sine theta. So this is a cos theta and this is a sine theta. Okay, good. So we need to remember this, right, at least till the NEET exam. All right, so just resolve this along two components. So you have g component through the angle, this will be g cos theta this is g cos theta and that's g sin theta. Let me use a different color. This is g cos theta, okay, and this one is g sin theta. So this is g cos theta and this one is g sin theta. So what is component along the plane? It's g sin theta, right? It is g sin theta. So which component is opposing? See, the object is shot up the plane and the acceleration is down the plane, right? The component of gravity is down the plane, so it is opposing this motion. Okay, so finally the velocity becomes 0 when it goes till the top. Finally the velocity becomes 0. Then you have v square minus u square is equal to what? It's equal to 2as, okay, or you can say 2ax1, 2ax, let's say. So then what is this component? The acceleration is minus g. So this is 2 times of minus g into sine theta into x, that is v square minus u square. Okay, v0 at the top, v is equal to 0, and therefore it is just u square is equal to 2g sine theta into x. Okay, u square is equal to 2g sine theta into x, right? So what's given here? So initially you take one plane which is inclined at an angle of 60 degree and object is shot from the bottom of that long smooth inclined plane. So it travels distance x1. Then in next case the inclination is decreased to 30 degrees. Okay, it's shot with the same velocity, same speed. Then it travels distance x2. So velocity is same, that means u1 is equal to u2. u1 is equal to u2 means what? 2g to sine theta 1 x1 should be equal to 2g sine theta 2 x2. Right, this thing is clear? Yes, no? Okay, good. So 2g gets cancelled out. So u is same means 2g is anyway constant. Sine theta 1 x1 is equal to sine theta 2 x2. So what is x1 is to x2? We want x1 is to x2. Sine theta 1 x1 is equal to sine theta 2 x2, and therefore x1 is to x2 is just equal to sine theta 2 by sine theta 1. And now you can put the values, that is sine of 30 degrees divided by sine of 60 degrees. So that is 1 by root 3, right, because sine 30 is 1 by 2, sine 60 is root 3 by 2. So that's 1 by root 3. Okay. So now this won't take any time. Now you just remember this thing. It will come in handy for this chapter, the next chapter, next to next chapter. What is next chapter and next to next? There is laws of motion, that is force, you can say, in that chapter also. Then there is work, energy and power. So inclined planes keep coming, okay, in these 3 chapters, and therefore you just remember this thing. If plane is inclined at an angle of theta with the x-axis, the component of gravitational acceleration along the plane is minus g sine theta, right? Component of acceleration is minus g sine theta. Okay, so it keeps on coming. So I guess there would be one problem at least based upon this thing, because it's there in 3 chapters. Okay, there will be definitely one problem on inclined plane. Almost every time there is. This is clear? Yes, no? Okay, good. So what's the answer? It's option D, 1 upon root 3. Alright, let's see next one. A particle has initial velocity, this one, and acceleration, this much. Speed after 10 seconds is. So just find out final velocity. So final velocity is equal to v bar is equal to, you can say, u bar plus a bar into t. Okay, but then yeah, so what is initial velocity? It is 3 I cap plus 4 j cap plus what is a bar? This is the a bar. Okay, so 0.4 I cap plus 0.3 j cap, and the time is 10 seconds. This is very simple question. Okay, so 3 I cap plus 4 j cap plus, so this is 10 times 0.4 is 4, so this becomes 4 I cap plus 0.3 times 10 is 3 j cap. So it is 3 plus 4 means 7 I cap plus 4 plus 3 means 7 j cap. So this is the final velocity. Yeah, option B, good. But they are not asking about the velocity, they are asking about the speed. So v is just equal to what? It is just equal to square root of vx square, you can say, plus vy square, that is the speed. That is 7 square plus 7 square means 7. You can say that this is 7, 2 times 7 square. So you can take 7 outside, so it's 7 root 2. Okay, and unit they have not given, so that means 7 root 2 units. That's the answer. This is very, very simple question. Okay, this thing is clear, right? Okay, so this is very simple question. So I don't expect, but I don't know. I mean, they can ask anything because they have asked very, very simple questions, formula based questions also. All right, let's see next one. two boys are standing at the ends A and B of a ground where AB is equal to A, small a. The boy at B starts running in the direction perpendicular to AB with velocity v1. Okay, so there is a playground and two boys are standing at the two ends of that playground. Okay, so this is a playground, let's say, and two boys are standing at two ends A and B. These are two ends, right? This is line AB. The boy at B starts running in direction perpendicular to AB with velocity v1. So boy at B starts running like this, perpendicular to AB, they are saying, with velocity v1, and the boy at A starts running simultaneously. Okay, so he notices that his friend is moving like this. Okay, simultaneously he starts running and catches the other in time t, and he wants to catch him, okay, in time t. So he cannot run like this, right? He has to run something like this. Okay, so suppose he runs something like this, right? He runs something like this. This is the velocity of this guy. Okay, he runs with the velocity v and catches the other in time t. Now in order to catch the other one, so catch B, how much should be the y component of his velocity? So let's say this is the y direction, okay, and this one is x direction. How much should be the y component of his velocity? Tell me. v1, exactly, that should be equal to v1. Okay, otherwise we cannot catch, right? It should be equal to v1 because they are starting at the same time. So this guy covers some distance in y direction, that one will be equal to v1 times t. This guy covers some distance in this direction, but now in order to catch him, suppose he moves here, he also has to move here, right? Okay, he also has to move here. So then what will be the distance covered in x direction? It will be equal to the length of this ground AB. The distance covered in y direction must be equal to v1 times delta t. Okay, the distance covered in y direction will be same, right? So you can say that v is equal to, what is v? Velocity of A. Velocity of A is equal to what? Of A means boy at A. It is equal to v bar, that's vx into I cap plus vy into j cap. But A catches B, let's call them A and B only, but A catches B in some time t, and therefore vy must be equal to v1, that is the velocity at velocity of the boy at point B. Okay, so then we want to find out that time, that is the thing. Okay, so what will be the distance covered in x direction in that time? Distance covered is equal to this one, okay, length of the ground AB. AB is equal to A, right? So distance covered in x direction is equal to AB, that's equal to A, right? So therefore you can find out what is Vx. Okay, what is Vx from there? So distance covered in x direction, would be equal to what? This much AB. So that is equal to, I can say AB, which is equal to A, will be equal to Vx times t. Okay, and you want time, so that time will be equal to t is just equal to this distance covered, okay, AB, or they are calling the distance equal to a divided by vx, velocity in x direction. Now can you find out this velocity in x direction? Because we want to find out the time. We know v bar is equal to this thing, right? So let me just add a page here. So v bar is equal to vx into I cap plus vy into j cap, and vy is equal to v1, so v1 into j cap, okay. So therefore v square, you can say it's equal to vx square plus vy square, that is v1 square, and from there you can say that vx square is equal to v square minus v1 square, and vx therefore is root of this thing, square root of v square minus v1 square, and therefore the time is equal to what? It is a upon vx, that's equal to a divided by this thing, square root of v square minus v1 square. So this is the answer, a divided by square root of v square minus v1 square, or if you put everything in root, then it will be option D. Okay, this thing is clear. Yes, Selva Kumar.
Clear, sir.
Okay, good. Okay. So this one was a good problem because you need to think a little bit in this question. All right, let's see next one. Rain is falling vertically downwards with a velocity of 4 km per hour. A man walks in rain with the velocity of 3 km per hour. The raindrops will fall on the man with the velocity of, tell me. Okay, so see, raindrops will fall on the man with relative velocity, of the rain with respect to man. Okay, for an example, suppose you are just standing on ground and a bus comes from other side, okay, and the bus is moving with speed of 1 meters per second, let's say, or let's say 10 kilometers per hour. So what will be speed of bus for you? It is just 10 kilometers per hour. But now suppose you are also moving in the opposite direction. What will be the speed for you? Suppose you are moving in opposite direction with 5 kilometers per hour, okay, and bus is moving towards you. So actually both are moving closer to each other with the speed of what? Relative speed, right? That is the 15 kilometers per hour. No, it will be 15 because they are moving in opposite direction. So this is 10 and this is 5. So actually you need to take minus 5 here, because this velocity, if you take it positive, then this one would be negative, right? It is 10 minus 5, that's the relative velocity. So it is 15, okay. So if you are also moving, then bus seems to be moving faster, right? It's like that. So here if you are also moving, now you must have noticed this, that if you are standing in rain or you are sitting on your bike, okay, you are on your bike but you are just sitting and you are enjoying rain, so the speed seems slower, but if you start moving, then what happens? You feel that the rain is moving faster, okay, rain is coming faster to you and its direction will also change, okay. its direction will also change. So see how. So see, rain is falling vertically downwards only, it's given. Rain is falling vertically downwards, okay, and with some speed 4 kilometers per hour. Man walks in the rain with the velocity of 3 kilometers per hour. So suppose man is walking in this direction, okay. So man is walking in this direction. So let's say man is walking like this in this direction with a speed of 3 kilometers per hour. Rain is falling like this. Okay, so this is velocity of rain, this is velocity of man, and you want velocity of rain with respect to man. So Vrm, that is velocity of rain minus the velocity of man. So if this is Vm, velocity of man, what will be minus velocity of man? It will be directed like this. Okay, now if you are steady, you will see that the rain is falling vertically downwards. But now if you are moving in this direction, let's say in forward direction, then you will feel that the rain is falling like this. Okay, rain is coming towards you at some angle. You can find out that angle, right? So this will be the resultant velocity, or you can say effective velocity of rain for you. This is velocity of rain with respect to man, right? This is Vr, this will be, this is Vm, okay. So this is minus Vm, and if you want to find out Vr bar minus Vm bar, then that is sum of Vr bar plus minus Vm bar. This thing is clear, everyone? Right, good. So therefore the velocity is directed like this, and therefore the rain seems to be coming at an angle, right? So what is the resultant velocity then? This is 3 and this is 4, so it's 5. Okay, so let me get rid of this man. All right, so Vrm is just equal to square root of Vr square plus Vr square plus Vm square, that is equal to square root of Vr square plus Vm square. 3 square plus 4 square, 4 square plus 3 square. Okay, that is 25. Square root of 25 is 5, and unit is kilometer per hour. Okay, so it is option D. This one is clear, everyone? Good. All right, then let's see next one. Rain is falling vertically downwards. Is that the same one? Yes, it's the same one. A man is walking due east at the rate of 2 kilometers per hour. The rain appears to him to come down vertically at the rate of 2 kilometers per hour. The actual velocity and direction of rainfall with the vertical respectively are. Okay, so now this is different. Man is moving in forward direction, let's say towards east, and the rain appears to him to come down vertically. So is the rain coming down vertically? It's not coming. Okay, it's not coming down, right? But not in vertical direction. So man is walking towards east like this. And what's the speed of man? 2 kilometers per hour. Speed of man is 2 kilometers per hour. 2 kilometers per hour. This is speed of man, let's say. Okay. And the resultant is like this. So what will be minus Vm? Minus Vm will be this one. this is minus Vm I'm sorry, this is minus Vm, and this one is resultant. How much? It appears to him to come down vertically at the rate of 2 kilometers per hour. Okay, so for him the rain comes down like this at 2 kilometers per hour. So this is effective velocity of rain, okay, for the man, right? This is velocity of rain with respect to man, velocity of rain with respect to man. This is not velocity of rain, okay? So how do we find the velocity of rain? We need to find out the vector. This one is shorter, I guess. So, okay. So see, if I complete parallelogram here, see velocity of rain would be like this, okay, this is VR bar. So the VR bar minus Vm bar will give you what? Vrm bar. Right? This thing is clear, everyone? Okay. This is Vrm bar. So now you tell me what's the direction of this VR bar? How much is the magnitude first of all? So option A, 2 root 2, 45 degrees. Yeah, that's correct. Okay, everyone. Right? So see, this much distance is what? It's 2. This is also 2, right? This is 2, this is 2, and you're drawing this. This is like a diagonal, you can say. Okay, if this is 2, this is 2, and this is also 2. Okay, so how much this distance will be equal to? This will be equal to 2 root 2. Okay, because this is a parallelogram, so this side and this side would be equal. So this is 2 and this is also 2. Okay, so if this is 2, then what you can say is, by Pythagoras theorem, this is 2 root 2, right? And then what will be this angle? So you can say that Vy, okay, or yeah, let's say Vy is 2, Vx is also 2. Okay, so this angle is equal to what? This is 45 degrees, right? Because tan of theta is, here it will be Vx divided by Vy, okay, or here it is Vm divided by Vrm. Okay, so this angle is going to be equal to 45 degrees. So Vr magnitude wise, it's equal to 2 root 2. Okay, by the Pythagoras theorem you can say, okay, it's 2 root 2, and the direction theta is equal to what? 45 degrees with the vertical. Right, so this is simple. Okay, good. Let's see next one. A river is flowing from west to east with a speed of 5 minutes per meter. Okay, speed is, sorry, 5 meters per minute, not minutes per meter, 5 meters per minute. Okay, a river is flowing from west to east with the speed of 5 meters per minute. A man can swim in still water with velocity of 10 meters per minute. In which direction should the man swim so as to take the shortest possible path to go to the south? A river is flowing towards west. So river is flowing like this. Okay, river is flowing like this. Towards west. Okay, and west to east, sorry, yeah, so that's correct basically. So this is going from west to east. Okay, so then and speed is given, and man can swim in still water with the speed of 10 meters per minute. In which direction should the man swim so as to take the shortest possible path? Tell me. So velocity of river is given, velocity of the man in still water 10 meters per minute, it is given. Okay, so shortest path is simple, right? So everyone agrees that this is the shortest path. Okay, so velocity of the river is given, it's like this. Velocity of river is like this, right? It's too broad. This is velocity of the river. Okay, so tell me, what should be the velocity of man? Shortest path is this one, right? So if he comes along this path, what will the river do? If the man is steady, then the river will take him along with it, right? Okay, he will move along the river current. But if man is moving, so if man is moving in this direction, what will be the effective speed, effective direction of moving? It's his velocity plus the river's velocity. Okay, so he will move like this. But if he wants to move in this direction, so actually he should move at some angle. Okay, at some angle like this. Okay, so what should that angle be? So let's check. So this is 10, right? So this is 10 and this is velocity of man. This must be velocity of man in still water, and velocity of the, oh, I'm sorry. Okay, so this is velocity of man in still water plus the velocity of river should result in this velocity, right? It should result in this velocity. So what you can say is Vm square. Okay, we just want direction. Okay, so what will be this angle? So this angle is theta. So you can say sine of theta is just equal to what? Velocity of the river, because this is velocity of river, divided by velocity of man. So that is equal to 5 by 10. So therefore theta is equal to 30 degrees. Right, 5 by 10 means it's 1 by 2. Okay, so sine of theta is 1 by 2 means theta is equal to 30 degrees. So this is very simple. But then there are two 30s. One is east of south, 30 east of south, 30 west of south. Which one? This is the south direction. Option D, it is 30 west of south. Right, that's correct. So it's option D. Okay, this one is clear. Yes, no? Right, good. So there can be questions like this. Alright, so this one is simple. A particle has initial velocity this much and acceleration of this much. So the magnitude of velocity after 10 seconds will be. So this is like a repeated question, right? So let's just skip this one. Let's see next one. A man is slipping on a frictionless inclined plane and back falls down from the same height. Then the velocity of both is related as. Tell me. Man is slipping on a frictionless inclined plane. Okay, so there is an inclined plane like this and man is slipping on this plane. Okay, and a bag falls from that height, from the same height. A bag falls. So what will be their velocities? Which one would be greater? Option A, velocity of B is greater than velocity of M. Why is it so? It's a frictionless plane. G cos theta is less than G. Yeah, that is true. G cos theta is less than G. But his acceleration would be equal to, acceleration along the plane would be equal to G sin theta. Okay. But here you can think of it this way. See, now it's not given that whether they cover equal distance, different distance. So this thing we need to take it for granted that they fall through same height. Okay, they fall through the same height. Right. So if they fall through same height, then now can you tell me the distance the velocities would be same or different? Yes, Yamini. The man is moving on the floor on this inclined plane, back just falls down. Okay, so the change in, yeah, it will be same. If they fall through the same height, then the velocities will be equal. So reason is just this thing. Okay, now we have not seen work energy and power, but I am just going to use a concept because I am sure you know about the potential energy and kinetic energy, right? So if the man and the bag, they are at some height, let's say h above the ground. Okay, so they are here, let's say. So the height changes, let's say by h, then what happens? Then what happens? The potential energy at this height gets converted to kinetic energy over here. Okay, initially the man is released, or we can say man starts sliding with 0 speed initially. Okay, right, this thing is clear? Yes, no? Okay, So initially he will have some potential energy, it gets converted to kinetic energy. That's it. Right? And that's why speed of man and speed of the bag will be same if they fall through the same height. Same height is given, that's why. Okay. All right. So this is also a simple question. Let's see next one. Speed of swimmer in still water is 20 meters per second. Now you answer me this one. Speed of river water is 10 meters per second and it's flowing due east. If he is standing on south bank and wishes to cross the river along the shortest path, the angle at which he should make his strokes with respect to north is given by. Tell me. So our other swimmer was on north bank and wanted to go to the south bank. This one wants to move from south to north. Okay. The velocity of river is west to east, right? Flowing due east. So velocity of river is west to east and man wants to move from the south to north along the shortest path. Tell me what should be the angle? This is velocity of man. No, this is the effective velocity. So what does that mean? The effective velocity would be in this direction. It means that he will try to move like this due west. Okay, but how much? So that depends. So this is his velocity. This is velocity of man. Okay, this is Vm bar, and then you have velocity of river. It's like this. All right, velocity of river is like this, and the effect of 2 is such that he moves in this direction along the shortest path. Okay, so velocity of man is directed like this, velocity of river is like this. Okay, and this is the angle theta. So he swims some angle, let's say theta, okay, due west. West of what? West of north. Okay, how much is that angle? So sine theta, you can say it will be Vr divided by Vm, right? Sine theta here also it's Vr divided by Vm. That is velocity of river is 10 and velocity of man is 20. So again it's 1 by 2 only. Sine theta is 1 by 2 means theta is equal to 30 degrees. Okay, this one is clear? Yes, no?
Yes, sir.
Okay, all right. So in this kind of question we can make one shortcut. Now it depends what direction they are asking about, right? So you can say that if he moves along shortest path, then at what angle will he make his strokes? So it will be just sine theta will be just equal to velocity of river divided by velocity of man. Okay, this question is quite repeated. You can see this question is quite repeated. Okay, or maybe in different exams they have taken it. Sometimes it is rain, sometimes it's man swimming across the river. Okay, 1-2 questions I have not taken because it's the same question basically. Okay, so the width of river is 1 kilometer, the velocity of boat is 5 kilometers per hour. The boat covered the width of river in shortest time, 15 minutes. Then the velocity of river stream is, tell me. So now there is a boat. Okay, so there is a boat and width of river is given. Now width is 1 kilometers. Okay, so boat covers this width of river in 15 minutes, just 15 minutes. Then the velocity of river stream is, velocity of boat is given. So once again the velocity of boat will be directed like this. Okay, this is velocity of boat, right? Boat must be moving in this direction. Let's use this velocity of boat. Velocity of the river will be directed like this. Velocity of the river will be directed like this, and this is the shortest path along which, as a result of these two, right, boat wants to move in this direction but river is taking it along the river current, and the result of these two is like this, it's moving in the shortest, along the shortest path. So if it can move in shortest time only if it is moving along the shortest path, right? So that is, what's that, 15 minutes. Okay, so here you can say VB square, what should we call this? Let's call this Vy. Okay, so VB square is just equal to VR square plus Vy square. Okay, but now do we know Vy? We want to find out velocity of the river. Do we know Vy? Yes, we know that it covers this much distance in what? It covers this much distance in 15 minutes. Okay, so Vy is just equal to distance covered, or you can say y divided by time. So 1 kilometer per 15 minutes, but we want it in kilometers per hour because the other velocity is in kilometers per hour to compare it. Okay, so you can just multiply this by 4, numerator and denominator. So then 15 minutes times 4 is 1 hour. Okay, so it will be what? 4 kilometers per hour, right? So you got Vy also. What will be Vr? So this is 5, this is 4, then what is this? Yeah, 3 kilometers per hour. Okay, remember the right angle triangle 3, 4, 5. So there is a popular right angle triangle where the ratios of 3 sides is 3, 4, 5. So if this is 5, hypotenuse is 5, the other side is 4, that means this is equal to 3, right? Okay, anyways, if you remember, that's very good. Actually this is very simple. It also keeps on coming, right angle triangle. Okay, so 3, 4, 5, that is popular ratio. All right, so we want to find out Vr. Vr will be just equal to square root of Vb square minus Vy square. Okay, so that is equal to square root of 5 square minus 4 square. Okay, so 25 minus 16, and that is 9, square root of that is 3. So that's why answer is 3. Right, that's very simple. All right, so let's begin with the next topic, that is the projectile motion. So this is an important topic in the sense that every every year there will be one question based upon this. Almost every year there is at least one question based upon this topic. So the name of the topic is projectile motion. So now what is projectile motion? It's very simple. Suppose you throw something in space, motion of that object is called as projectile motion, and that object is known as a projectile. Okay, so now suppose you have some object, a ball, or suppose this pen, you throw it from this point, you call it an origin. Okay, so this is the origin, starting point, and then at this point suppose you throw this ball in this direction. Okay, so this is the direction in which you throw the ball. So initial velocity is suppose u bar, right? Initial velocity is u bar. Then now what do we want to know about this object is how high does this object go, okay, from the starting position. Then how far does this object go, right? So how high this object goes, that height is known as the maximum height achieved by the object. How far does it go, so that distance to which it goes, it is known as the maximum range. It is known as horizontal range, okay, and maximum value of that is called as maximum range, right? So this is horizontal range, distance covered along the ground. Then after that, what time does it take? So the time that it takes to go to this point, it is known as time of flight. Time it takes to attain the maximum height is known as time of ascent. Okay, and time it takes to go from this point to this point, that is from maximum height again to the ground, it is known as time of descent. So now we want to know all these things. And also we know that if you throw the ball or any object like this, its path looks like this, right? You throw something in air, its path looks like this. So what is the equation for the path, right? So this is a parabola. Okay, this is a parabola. So equation will be something like a parabola, right? Equation of parabola. So standard parabola is y is equal to something, some constant c into x square. This is standard equation of parabola. But then there can be some term having x also. Okay, here you have second power of x. There can be some term having first power of x also. So we want to find out all of these things, right? And again we need to remember them. Alright, suppose you throw this ball or any object like this in space with initial velocity u bar. So now this u bar can be resolved in two components. So angle that it makes with the horizontal, it is suppose theta. So this ux is the horizontal velocity, uy is vertical component of velocity. This horizontal component of velocity ux will be equal to u cos theta, right? Remember, component through the angle is cos component, component away from the angle is sine component, right? So ux is u cos theta, uy is u sine theta. And then how can you write the u bar? U bar can be written as ux into I cap plus uy times j cap. Okay, so this is just plain resolution, right? After that, there is an important point to be remembered. Now there is only one force acting on this object if we neglect the force due to air. Okay, that is frictional force. If we neglect that, because it will be very small, so there would be only one force acting on this object when you throw that object in space, that is the force due to gravity, right? So there will be only one acceleration also, that is the acceleration due to gravity, and it is acting in vertical direction. So the vertical component of velocity will only change and the horizontal component will remain constant, because there is no acceleration in horizontal direction. So horizontal component of velocity will remain constant. So this is an important point. So everywhere the horizontal component remains constant. That means at the starting point the horizontal component of velocity is ux. At this topmost point also the horizontal component is ux. At this point it is ux. Ux is equal to u cos theta, right? So this is an important point, right? So then now you can just say that at the highest position, what will happen to the vertical component of velocity? Anyone? At the highest position, what will happen to the vertical component? Tell me. See, if you throw something in space, if vertical component of velocity, if it has some velocity in vertical direction, then it will keep on moving in vertical direction, right? That means it will, that is not the maximum height. If vertical component of velocity is not 0, then that's not the maximum height. Then it will keep on moving further. Okay. So when it attains the maximum height, what will happen? What will happen then? The vertical component of velocity will become 0. This thing is clear, everyone? Alright, good. So then if vertical component becomes 0, horizontal component remains constant, then at the maximum height, the velocity is only horizontal velocity, and that is equal to ux, right? At maximum velocity, at maximum height, what velocity does this projectile have? It is just the horizontal component of velocity, that is u cos of theta. Okay, just remember that at the maximum height there is only horizontal component of velocity, no vertical component of velocity. Okay, after that, next let's see equation for the path of projectile. So see, at start point, let's take x naught equal to 0, y naught equal to 0. Then we know the displacement along x-axis. What is displacement? It is just velocity into time. Why is it velocity into time? Because this is just uniform motion along x-axis. Okay, there is no acceleration. So displacement can be written as final position minus initial position, final x position minus initial x position, that is x minus x naught, and that is ux into t. If you take x naught equal to 0, then you just get x is equal to ux times t. Okay, x is equal to ux times t. That's very, very simple. And from that you can find out time. Okay, the relation between time and x is what? Time in terms of x is t is equal to x divided by ux. Just take that ux on this side. Okay. After that, then displacement along y-axis. Y-axis means vertical direction. So that is uniformly accelerated motion. How much is the acceleration? If you are throwing the object upwards, okay, or at some inclined angle, then what is the acceleration? For vertical component of velocity or for vertical component of motion, the acceleration is vertically downwards. Okay, you are throwing the ball up or throwing the object up and acceleration is down. That means you need to take it as minus g, right? You need to take it as minus g. So displacement along y-axis, you will write sy, okay, y component of displacement, it is uy times t plus half of ay times t square. So because this is uniformly accelerated motion, we used kinematic equation, right? So then what is ay? So ay is equal to minus g. You put that here, so you get sy, which is y minus y naught, is u sin theta into t, that is u sin theta is the y component of velocity, u sin theta into t minus half of g into t square. Okay, and then you put y naught is equal to 0, then you get y is equal to u sin theta into t minus half of g into t square, right? So you get this equation. Then if you put this thing, you want relation between y and x, suppose, then you put t is equal to x upon ux, that is x divided by u cos theta. Here what do you get? Then while when you substitute that, you will get some step in between. Okay, if you put that, so x divided by u cos theta here in place of t, then this u and u will get cancelled. Okay, in place of this t square, there will be x square divided by u square cos square theta. and if you do that, you will get y is equal to tan theta times x minus half of g divided by u square cos square theta into x square. You get this thing. This thing is clear, everyone? Yes, no? Right? So then what you can do is you can write this as y is equal to tan theta. Since you throw that object with some initial angle, with some initial velocity, so both of them are constants, right? Initial angle is constant. Once you throw it, you cannot change it, okay? And initial velocity is also constant. So this thing is a constant. Theta is constant means tan theta is a constant. So you can write this thing as alpha, and initial velocity is also constant. So magnitude of initial velocity you cannot change once you have thrown it, right? So this thing is a constant. So you can put some other constant beta in place of this thing. This whole thing is constant. So then you get y is equal to alpha times x plus beta times x square, where your alpha is tan of theta and your beta is minus g divided by 2u square cos square theta. Okay. Then if you look at this equation, you have y is equal to something times x plus something times x square. Something means some constant times x plus some constant times x square, right? So this is called as this is the equation of path of projectile or trajectory of projectile, because it is relation between y and x, right? So if you take some values of x, and for those values, if you substitute those values in this equation, you can find out the values for y, and then you can plot the graph between them, and that's why this is known as what? Equation for trajectory or path. Okay, this thing is clear? Yes, no? Okay, and this is an equation of a parabola. Okay, so standard parabola will have equation y is equal to some constant, let's say beta times x square. There is an extra term over here, that is alpha times x, okay, which will extend this parabola. So suppose standard parabola looks like this. Because of this term, this will look like something like this. Okay, so you can say this is an extended parabola, but it's a parabola only. This is this thing clear? Yes, no? Okay, good. So then we need to remember this equation, okay, because it's not I mean, there haven't been questions directly based upon this. We could solve those questions using some tricks, but then you don't know if there is direct question like this. What is an equation of parabola? Option A, B, C, D. Okay, not parabola. What is the equation of the trajectory of projectile? If they ask a question like this, then this is the equation, right? There might be a direct question also. You don't know. For that sake, just remember this. All right. Then we need to find other things, the maximum height, okay, horizontal range, etc., etc. So for maximum height, we have just discussed what will happen to the vertical component of velocity at maximum height. It will become 0, okay, and then we can just use this equation, v square is equal to u square plus 2as, right? We can use that equation. V square is equal to u square plus 2 times a into s. Okay, so here we are discussing the y component of velocity, therefore suffix will be y everywhere. Okay, so it is vy square is equal to uy square plus 2 times of ay into s. S is the displacement. So then what is ay? Ay is equal to minus g, so put that here. What is displacement? So displacement from the starting point is just the maximum height, right? Displacement in y direction, it is just the maximum height. So therefore put h over there. So then vy is equal to 0, vertical component of velocity is 0, that means uy square minus 2gh is 0. So ui square is equal to 2gh, and from that you just get h is equal to ui square divided by 2g. And what is uy? So ui is equal to u sin theta. Just put that. So you get h is equal to u square sin square theta divided by 2g. Right, h is equal to u square sin square theta divided by 2g. So this equation also we need to remember. Right, whatever equations are coming, we need to remember them. Okay. So this one is clear? Yes, no? All right, good. So then next we want to find out the time of ascend. Now what is ascend? Ascend is meaning is clear from the name, right? It's moving up. So time till which it keeps on moving up, the projectile keeps on moving up, it is known as time of ascend. So Vy is equal to ui plus ay into t, we can say. Okay, first kinematic equation. So we are using it for y direction. So what is Vy at the maximum height? It is 0, right? And what is ay? Ay is minus g. So using that, you get Vy is equal to ui minus gt. At maximum height, Vy is 0. Just put that. So this thing is 0. That means ui is equal to gt. If you move this minus gt on other side, ui is equal to gt. And at maximum height, to reach till maximum height, the time that you require, it is known as the time of ascend. So what is time of ascend? It is time required or time taken by an object to reach the maximum height. We denote it by Ta, T suffix a for ascend. Okay, just put Ta in place of this T, right, for the time of ascend, and then you get ui minus g times t is 0. So t is equal to Ta. Then you move this thing on other side. So you get Ta is equal to ui divided by g, and you put ui is u sin theta. Put ui is equal to u sin theta, then you get this equation. So time of ascend is equal to u sin theta divided by g. Right? So this thing is clear? Yes, no? Everyone? Okay, good. And then time of ascend and time of descend. So time taken by projectile to go from maximum height to the ground, to come back to the ground, it's same. Okay, these both these times are u sin theta divided by g. Right? How we can find it out, but you just need to trust me over that. Okay. All right. Next is, let's find out time of flight. So what is time of flight? The maximum time for which the projectile is in flight. Okay, it's flying. That is known as time of flight. So how do we find that? So now see, if we are talking about the projectile motion where this horizontal, you can say the ground is leveled, okay, the floor is leveled, then what will happen to the y? What do I mean by y? What will happen to the y coordinate? Okay, so my question is, when you throw some object in air, okay, from the ground, and it is leveled ground, okay, that means it's perfectly horizontal. So when you throw it and it comes back to the ground, so initial y component, or not y component, y coordinate was 0. So what will be final y coordinate? It will also be 0. Right? Yes, no? Okay, so y coordinate will be equal to 0. Okay, so then you have this equation, y is equal to uy times t minus half of gt square, and uy is u sin theta. Okay, so using that equation, put y equal to 0. If you put that, you get u sin theta times capital T. What is capital T? So y will again become 0 when time is equal to what? Time of flight. So that is capital T. So 0 is equal to u sin theta into t, capital T, minus half of g times capital T square. So then move this thing, the capital T, sorry, half of g into capital T square on the other side, or here itself you can take t common. If you take t common, then you have u sin theta minus gt by 2 is equal to 0. Okay, t times u sin theta minus gt by 2 is equal to 0. So this implies that either t is equal to 0 or this bracket is equal to 0. So t is equal to 0 means what? That's the starting position. Okay, so at t equal to 0, y is equal to 0. We know that, but we don't want that. We don't want that case. So if we take the other case, that this bracket is equal to 0, that means if we solve this, then we get t is equal to 2u sin theta divided by g. Okay, just taking this term on other side, we get time of flight is 2u sin theta divided by g, and then this is the total time of flight. This is total time of flight. If you just subtract the time of ascent from it, you get time of descent. So total time is 2 times u sin theta upon g. Time of ascent is u sin theta upon g. That means what remains is u sin theta upon g. So time of ascent is equal to time of descent. Right, this is clear? Yes, no? Okay, good. All right, then next let's talk about the range of projectile. So what is range of projectile? So the maximum horizontal distance to which the projectile goes, the horizontal distance that projectile covers in its motion, okay, in the projectile motion, it is known as range. So this distance is called as range. So what will be range then? It's the horizontal distance that it covers. So what is horizontal distance? It is just horizontal velocity, horizontal component of velocity multiplied by the time that it takes to go from here to here, right? Time that the projectile takes to go from here to here, and that is just time of flight. So you have r is equal to horizontal component of velocity ux, which is u cos theta, and time of flight is 2u sin theta upon g. If you multiply that, you get u times u is u square. U square multiplied by, you have 2 times sin theta cos theta, okay, upon g. And what is 2 times sin theta cos theta? So if you remember half angle formula, okay, or double angle formula, whatever you call it, 2 sin theta cos theta is equal to sin 2 theta. So then you have r is equal to u square sin 2 theta divided by g. This is the range of projectile. Right, this thing is clear? Yes, no? All right, very good. So then now suppose I want to find out maximum possible range, that is r max suppose. So for that, this term sin 2 theta must be equal to 1. For maximum horizontal range, sin 2 theta must be equal to 1, right? So put sin 2 theta equals to 1, then you get 2 theta equals to 90 degrees. That means theta is equal to 45 degrees. So at which angle, when you throw an object, at what angle should you throw it to attain the maximum range? So that angle is 45 degrees. Okay, this is clear? Yes, no? Right. So that means suppose you are playing cricket. You will not play at this time, but suppose you are playing cricket, okay, and you want to throw a ball. You are at the boundary, fielding at the boundary. You want to throw a ball, and you want to take minimum efforts. Minimum efforts. So at what angle should you throw the ball to the keeper? So you should throw it at 45 degrees, because when you throw the ball with the same velocity, you are throwing it at same velocity, means let's assume that you are putting on same efforts, you are putting same efforts, right? So you should throw it at 45 degrees. Okay, this thing is clear, because then only it will cover the maximum range. For the same efforts, the maximum horizontal distance covered is more. Okay, all right, this is how we can apply it in practical life. This thing is clear? Yes, no? Okay, good. So this is range of the projectile. Then, so this is all that we need to remember, as far as the equations go. And one more thing, what will be the maximum height? So h is equal to, you have u square sine square theta divided by 2g. So their sine square theta will be equal to 1, right? Sine square theta will be equal to 1. Okay, so maximum height is u square upon 2g. What do you think? When will you have the maximum height? At what angle with the horizontal should you throw the ball? (90°), exactly, right, very good. So you should throw it at 90 degrees to the horizontal, okay, right, because sine 90 is 1, sine 90 is 1, so sine square of 90 is 1, so then you get h is equal to u square by 2g, okay. So maximum height is u square by 2g and maximum range is what? U square by g. Okay, so that thing is covered here. For h to be maximum, you want h maximum, then sine square theta must be equal to 1, that means theta is equal to 90 degrees, and then h max is equal to what? U square divided by 2g. You get that, okay. So at this angle at 90 degrees, what do you think will be the horizontal range? When you throw the ball vertically upwards, what will be the horizontal range? 0, exactly. So horizontal range will be equal to 0, okay. All right, so then let's see some observations. Equation of velocity when the projectile hits the earth, okay, let's talk about that. So initially, suppose you're throwing the ball, it's like this, so you throw it at an angle of theta. So now see, this whole curve is symmetric, okay. This curve means the path of projectile is symmetric. So you throw the ball or any object at an angle theta, it will hit the ground at an angle theta only, okay. It will hit the ground at this angle. Let's say it hits the ground at this angle, okay. This angle will also be equal to theta, right? Okay, if this angle is theta, this angle is also theta. So this is the angle made by its path, or let's say angle made by its velocity, velocity of the projectile with the positive x-axis, okay. So the magnitude of angle is theta, but now what about the direction? Tell me. Is this thing clear? Yes, no? The question is clear or not? Okay, so question is, suppose the projectile is thrown at an angle theta, it hits the ground, so this angle will also be equal to theta, right? So it's coming, the projectile is coming this way, it's moving this way, right? So then it goes like this. So what will be the angle made by its velocity, okay, angle made by its velocity with the positive x-axis? So if we talk about the magnitude of angle, it's equal to theta, but then we remember this thing that if you measure an angle anti-clockwise, it's positive angle. If you measure an angle clockwise, it's negative angle. So then if theta is written and also minus theta is written in the options, which one would be correct? Yeah, minus theta would be correct, okay. This thing is clear because you are going in clockwise sense to measure this angle, so minus theta would be correct, right? So magnitude wise theta is correct, but to measure this angle you are going in clockwise sense, so clockwise angles are negative, Okay, this is clear, everyone. Selva Kumar.
Clear, sir.
Okay, good. So it will be minus theta, just remember that. But then now suppose, see, this is the initial velocity and final velocity at this point. So if you apply the law of conservation of energy, the energy with which you are throwing the ball and energy with which it's coming to the ground, because the potential energy will become 0. Okay, potential energy is equal to mgh, height becomes 0, height here is 0, and when it comes back to the ground, height again becomes 0. So the potential energy is 0. All energy that the ball has, ball or any projectile, it is just the kinetic energy, and that means the speed at this point and speed at this point will be equal. Okay, what else is equal? The horizontal component of velocity at this point and horizontal component of velocity at this point is also equal. Okay, then that means the vertical component will also be equal, right? But there is only one change, that here the vertical component is directed upwards, because this is ascending motion, and when it comes back, the vertical component will be directed downwards. Okay, so if here the equation for velocity when it starts can be written as what? It can be written as u bar is equal to ux into I cap plus uy times j cap. This is the equation of its velocity, right? U bar is equal to, you have just resolved u bar into two components, ux into I cap plus uy times j cap, and here what will be the equation for velocity? V bar is suppose equal to Vx into I cap plus Vy times j cap, but Vx is just equal to Ux, right? Vx is just equal to Ux. What about Vy? Vy is equal to minus Uy. Okay, Vy is equal to minus of Uy. This thing is clear. Horizontal component remains same, the vertical component is flipped. Okay, the sign of vertical component will be negative. So suppose this is 2i plus 3j, then what will this be? This will be 2i minus 3j. Right? Got it? Yes, no? Okay, very good. So please remember this thing also, because there can be a question based upon this. And then there is relation between the maximum height and range. Okay, what's the relation between maximum height and range? So this is the equation for range, u square sine 2 theta divided by g. This is the equation for maximum height, it is u square sine square theta upon 2g. If you divide h by r, then what happens is u square will get cancelled. Okay, then one of the sine theta in this square will get cancelled. Okay, and then that one sine theta will remain there. Okay, and g gets cancelled. So what remains is h upon r is just equal to, it is h upon r is just equal to what? Tan theta by 4. Okay, this 2 times 2, it will be tan theta by 4, and if you simplify that, you will get tan theta is equal to 4h divided by r. Tan theta is equal to what? 4h divided by r. Okay, and this is true for any angle. This thing is true for any angle of projection. Tan theta is equal to 4h divided by r is true for any angle of projection. Right? This thing is clear? Yes, no? All right, good. And then there is one more thing. So now suppose equation for the path is given, that y is equal to, suppose 5x minus 10x square. This kind of equation is given. So suppose equation for the path is given, y is equal to 5x minus 10x square. This is the equation for path of projectile. So how do we find the range? Okay, so this is your alpha and this is your beta. So the trick to find out range is just do alpha divided by beta. That is, here it will be 5 divided by 10. That means 0.5 meters. Okay, this thing is clear? Yes, no? So the horizontal range will be just equal to magnitude of alpha by beta, 5 by 10. That is 0.5. If this kind of equation is given. Okay, so you can see how does it work. So you have y equals to tan theta times x minus g divided by u square cos square theta into x square. So this is your alpha. Alpha is tan theta, so that is sin theta by cos theta. And what is beta? Beta is equal to this thing. If you divide by this, means you have to multiply by its reciprocal, right? So it's this thing. So then what will happen here? This cos theta and one of the cos theta from the square will get cancelled out, and you get 2 times u square, u square 2 times sin theta cos theta upon g. So that is equal to the range, and you have not taken this negative sign. Okay, so if you do this thing, you get the range. This thing is clear? Yes, no? Okay, so if we remember this, we can find out the range very fast. Otherwise, we need to take some efforts. Okay. All right. So this is all the theory that we need to remember. Now let's see some problems. So let us see some simple problems first. Let's see this one. The equation of trajectory of projectile is y equals to 10 times x minus 5 by 9 x square. If we assume that g is equal to 10 meters per second square, then the range of projectile in meter is, tell me. Option C is 18. Okay, let's see. Alpha is equal to 10. Beta is equal to what? Minus 5 by 9. So range is equal to alpha by beta, the magnitude of that, and that is 10 divided by 5 by 9. That 9 will go to the numerator. This thing becomes 10 times 9 is 90. 90 by 5 means 18. Very good, that's correct. So option C is the answer. Right? So it's very easy to find out range of the projectile. Okay, very good. Then we'll come to this one. This one also. Let's see this. A body is projected at an angle of theta with respect to horizontal direction with velocity u. The maximum range of the body is, tell me. A body is projected at an angle theta with respect to horizontal direction with velocity u. The maximum range of the body is. Yeah, everyone is saying option C, correct. No, Indusha, it's not option A, maximum range. So formula for range is u square sine 2 theta divided by g. Okay, for R max will be equal to what? U square by g, because the sine 2 theta, what is the maximum value of sine? It's 1, right? Sine or cos, maximum value is 1. So for R max, sine 2 theta will be equal to 1. So that means R max will be equal to, maximum range will be equal to u square by g. Right, good. So it's option C. Okay. Then during projectile motion, the horizontal velocity, tell me. Option D, yeah, it's always constant. Right, horizontal component of velocity remains constant because there is no acceleration in horizontal direction. That's very simple. Okay. Then let's see this one. the maximum height attained by a projectile when thrown at an angle theta with the horizontal is found to be half the horizontal range. So maximum height h is equal to half the horizontal range. This is given. Then theta is equal to, tell me what should we do? We have tan theta equals to what? 4h by r, right? It's option A. Let's check. So tan theta is 4h by r, that is 4 times h is equal to half of r, means r is equal to 2 times h. Okay, so h divided by 2 times h, so this thing is equal to 2, right? So everybody got this answer, right? So therefore theta is equal to tan inverse of 2. Theta is equal to tan inverse of 2. Okay, so this is simple, right? Very, very simple. Okay, let's see this one. A bullet fired at an angle theta 30 degrees with the horizontal hits the ground 3 kilometers away. By adjusting its angle of projection, can one hope to hit a target 5 kilometers away? A bullet is fired at an angle of 30 degrees, okay, and by adjusting its angle of projection, can one hope to hit a target of 5 kilometers away? Assume the muzzle speed to the same and the air resistance is negligible. Muzzle speed remains same, air resistance is negligible. You tell me, everyone, what should we do here? Okay, so let's see. See, you have r is equal to u square sine square theta divided by g, right? And r max is just equal to what? R max is equal to u square divided by g. Okay, then this sine square theta becomes what? Oh, what did I write? Sine square theta. So u square sine 2 theta divided by g. So r max is equal to u square by g, then the sine 2 theta becomes equal to 1. So now you divide r max by r. If you divide r max by r, what do you get? It's equal to, if you divide by that, then u square by g and u square by g will get cancelled. So this is equal to 1 upon sine 2 theta only, right? This is just equal to 1 upon sine 2 theta. What is r max? R max is equal to r divided by sine of 2 theta. So just put that. So what is the angle? It's 30 degrees. So r is equal to 3 kilometers, right? 3 kilometers divided by, let's keep it in kilometers only, sine 2 theta means sine of 60 degrees. How much is that? Sine 60 is root 3 by 2. Okay, so take the 2 in the numerator. So the answer will be 3 divided by root 3 into 2, that is root 3 times 2. So 1.73 times 2, right? So that is something like, what is 1.75 times 2 is 3.5. So near about 3.5, you can say 3.5 kilometers. Okay, so can you aim for a target which is at 5 kilometers away? Maximum horizontal range is just 3.5 kilometers, so you cannot aim, right? You can't aim. Okay, it is not at all possible with this speed to reach the target at 5 kilometers. Yeah, very good. So its answer is option B, not possible to hit a target 5 kilometers away, right? So that is very, very simple. Okay, so this thing is clear, everyone? Yes, no? All right, good. So now let us see some recent questions. A bullet is fired from a gun at a speed of 280 meters per second in direction 30 degree above the horizontal. The maximum height attained by the bullet is, this is from NEET 2023, and they say that it is based upon NCERT, page number 78. All right. So tell me, bullet is fired from gun at speed of 280 meters per second and in the direction 30 degree above the horizontal. The maximum height attained by the bullet is. So here the direct formula is applicable. H is equal to what? U square sine square theta divided by 2g. So that is 280 square, okay, times sine square of 30 degrees. Sine of 30 square, right? What is sine 30? Sine 30 is half. The square of that will be 1 by 4, is 1 by 4, and then use 2 times of this thing. G is 10, right? So then this thing you want 280 square, so that is 28 times 10 square and 28, yeah, so 28 square. So this thing divided by 4 is, I can say it is 14 square. And what is 14 square? Anyone?
$196.
196. 196 times you have 100 from here, okay, and divided by 20, or this thing is 10. 196 divided by 2, so it is 980. Oh, this one maybe 1000 meters, because we took G equals to 10. If we take 9.8, it will be closer, right? Check my calculation if that's correct. Let's get answer from 1 or 2 students. So option C, yeah, everyone is getting option C. Okay, good. All right, so this is direct question and there is nothing difficult in this one if we remember the formula, right? Let's see next one. This is not NEET, RS, some other exam. A cricket ball is thrown by a player at speed of 20 meters per second in direction of 30 degrees above the horizontal. The maximum height attained by the ball during its motion is. So this is exactly, I mean, similar question, and here they asked us to take G equal to 9.8, but that's difficult to do, right? So dividing by 9.8 etc, we are not going to do that. So that's why we'll see the closer options, right? Okay, here a cricket ball is thrown by a player at a speed of 20 meters per second in direction of 30 degrees. So H is equal to U square sine square theta divided by 2g, and that is just 20 square multiplied by sine square theta. This is 20 square multiplied by, you have 1 by 4 because sine of 30 is 1 by 2, and then divided by 2g. 2g is 20. So one of the 20 gets cancelled out from here, then 20 by 4 means 5. So answer is just 5 meters. Okay, so this is also very simple, right? Very straightforward. Okay, let's see next one. A ball is projected with velocity 10 meters per second at an angle of 60 degrees with vertical direction. So this is 60 degrees with vertical direction. Okay, that means 30 degrees with horizontal direction, right? This is from NEET 2022. Okay, so careful reading is required, otherwise we can take theta is equal to, we might take theta is equal to 60 degrees. Okay, that's not true. Its speed at highest point of its trajectory will be, okay, but then again it's not required, because tell me what will be speed at highest point, not the y component of speed. Tell me. A ball is projected with a velocity 10 meters per second at an angle of 60 degrees with vertical direction. Its speed at the highest point of its trajectory will be, option A. Okay, let's check. So it is 30 degrees with the vertical, means, sorry, 60 degree with vertical means 30 degree with horizontal. Okay, so theta is equal to 30 degrees. Then what is the speed at maximum point, maximum height? It is ux. Ux is equal to u cos theta. So that is 10 multiplied by, what is cos of theta? Cos of 30 is root 3 by 2. So that is 10 by 2 is 5 root 3. Yeah, so that's very simple. Because at the maximum height, what will happen to the y component? Y component will become 0. So what is speed? It is just the x component of velocity, and that is u cos theta, right? So 5 root 3 is the answer. Okay, got it everyone? All right, very good. So a simple question. Let's see next one. Two bullets are fired horizontally and simultaneously towards each other from rooftops of two buildings. So this question was given in the test. Okay, all right, so let us just skip this because some of you have not given test, right? It can be solved without using the concepts in projectile motion. All right, let's see next one. Assertion: the maximum height of projectile is always 25% of maximum range. For maximum range, projectile should be projected at 90 degrees. Tell me which one is correct. Assertion, reason. The maximum height of a projectile is always 25% of maximum range, and for maximum range, projectile should be projected at 90 degrees. So option C, assertion is correct, but reason is incorrect. Okay. All right. So reason is incorrect. That's clear. The maximum range, for maximum range, projectile should be projected at 90 degrees. This is incorrect. If you project it at 90 degrees, it will go upwards and come back at the same point. So range will be equal to 0. Okay, so range is equal to 0. So this is incorrect, right? But then assertion is correct or not? So you know, okay, for maximum range, the angle is equal to, theta is equal to what? 45 degrees. If we take that, then we know tan of theta is equal to 4h by r. Okay, and if you put that angle, so then you get tan of 45 is 1, So 1 is equal to 4h by r. That means what is height? It will be r by 4. Okay, so for this case it is true that h is equal to r by 4. Right, means h is equal to 25% of r. So for this case, if you consider the maximum range and from that you find out the maximum height, then h is 25% of r. Okay, the maximum height when the ball is projected at 45 degrees, then h is equal to 25% of r. Okay, in other cases it will not be true, right? If you change the angle of projection, it will not be true. Okay, so I guess this question is asked this way: you throw a ball in such a way that it goes to the maximum range, then what will be the maximum height, right? So in that case h will be 25% of r. Yes, no? Right, so in that case assertion would be correct and reason would be incorrect. So this is the answer. Okay, but if you change the angle, it's not always that h is equal to 25% of r. Right, if you change the angle. Okay, but they are saying maximum height of projectile is always 25% of maximum range. So that means you want maximum range, you are fixing the angle, and for that motion you are finding out the height. Right? Okay, this thing is clear? Yes, no? Okay, if you change the angle, this will not hold true. Right, everyone? Indusha? Alright, good. So if you fix the angle in such a way that it attains the maximum range, then this thing will be true. Okay. Alright, then let's see next one. What is the range of projectile thrown with velocity of 98 meters per second? I guess that will cancel out with 9.8. Right, that's why they have given 98 with angle of 30 degree from horizontal. Okay, so this is very simple. So r is equal to what? U square sine of 2 theta divided by g. So u square is 98 square. So let's take 98 times 98. Sine of 2 theta means sine of 60 degrees, and you have g. So here we'll definitely take 9.8. 98 divided by 9.8 is 10. So that is 980. 980 times sine 60. 980 times sine 60 is root 3 by 2. Okay, so that is 980 by 2 is 490. 490 root 3. So this is the answer. Right, that's very simple. Okay, then most of the questions will be simple. Let's see next one. When theta is 45 degrees or 135 degrees, the value of r remains the same. Only the sign changes. Only the sign changes. Okay, so both assertion and reason are correct, and reason is correct explanation of assertion. Tell me which one is correct. Okay, so now just remember this thing as a fact. If sum of two angles of projection is 180 degrees, if sum of two angles of projection is 180 degrees, then r is same, okay, but on opposite side of point of projection. Okay, just remember this thing as a fact. Okay, we'll solve this, but just remember this thing. Okay, so let's see how. So here what's given, it's theta is 45 degrees and 135 degrees, means theta 1 is 45 and theta 2 is equal to what, 135. Okay, so you have theta 1 plus theta 2 is equal to what, 45 plus 135, it's 180 degrees, right, 180 degrees or 2 pi you can say. So then range in first case, r is equal to what, u square sine 2 theta upon g. Let's find out what is the range in the second case. Okay, range in the second case. So for that, we have r, let's call it as r2. So r2 will be equal to u square by g, that thing is common, multiplied by, you have sine of 2 theta 2. Okay, so that is equal to u square by g multiplied by sine of, in place of theta 2 I will put 180 of pi minus theta 1. Okay, and then you can multiply by this 2, so you will get u square by g multiplied by sine of 2 pi minus 2 theta 1, right. Okay, so then this is r2 will be equal to, so what is this thing, sine of 2 pi or sine of, you can say 0 minus 2 theta 1, right, because sine of 2 pi is sine of 0. So this is just minus sine of 2 theta 1. Okay, this is just minus sine of 2 theta 1. You can always replace 2 pi, 4 pi, 6 pi, any even multiple of pi with 0. Okay, and then this formula will be applicable. Sine of 2n pi minus theta is minus sine theta, right. Or if you don't remember, let's just solve it. Okay, so you have u square divided by g, and then you have sine of 2 pi minus 2 theta 1, so that is just equal to sine a cos b. Okay, so that is sine 2 pi multiplied by cos of minus 2 times of what, minus 2 times theta 1, and minus, because there is negative sign here, minus cos of 2 pi into sine of 2 theta 1. Then you know sine 0 is 0, sine of 360 is 0, that is sine of 2 pi is 0. So this first term will become 0, and cos of 2 pi is equal to 1. So the second term will become what, minus of sine of 2 theta 1. So this is just equal to, okay, this thing is just equal to minus of sine of 2 theta 1, right. And then this is minus of u square by u square sine of 2 theta 1 by g. And what is r1? r1 is u square sine 2 theta, or let's say u square sine 2 theta 1 by g. r2 is just equal to minus u square sine 2 theta 1 by g. So if r1 is on right hand side, r2 will be on left hand side, but the magnitude is equal, right. This thing is clear, everyone? Yes, no? Alright, good. But then we'll not solve this in exam, we'll just remember this thing. Okay, so let me just comment it. So this is one comment, and there is another comment that I want to make. All right, so remember this thing. Okay, as well as one more thing, if sum of two angles of projection is 90 degrees, then R is same at and on same side of the point of projection. Okay, so this is for theta 1 plus theta 2 is equal to 180 degrees. Then R is same, but it is on opposite side of point of projection. If theta 1 plus theta 2 is 90 degrees, then R is same and it is on the same side of the point of projection. Okay, this thing is clear? Yes, no? So remember these two things. Right. Okay, let's see next one. If angle of projection of a projector with same initial velocity exceed or fall short of 45 degree by equal amount alpha, then the ratio of horizontal ranges is. Okay, so this is the second case. If angle of projection of a projector, or they should have said projectile, not projector, projectile with same initial velocity exceed or fall short of 45 degrees by same amount alpha. So let's say theta 1 is equal to 45 plus alpha and theta 2 is equal to 45 minus alpha. Okay, then ratio of their horizontal ranges is. So just check what is theta 1 plus theta 2. If they are giving two different angles, just check what is theta 1 plus theta 2. So 45 plus alpha plus 45 minus alpha, so plus alpha minus alpha will get cancelled out. 45 plus 45 is 90 degrees, right? So sum of these two is 90 degrees. That means what is the ratio of the ranges? It's 1 is to 1. Okay, this thing is clear? Yes, no? Everyone clear, not clear? All right, good. And to check that is also very simple. So see, let's say R1 is equal to u square sine of 2 theta 1 by g, that is u square 2 times sine theta 1 cos theta 1 by g, right? What will be R2? So R2 is equal to u square multiplied by 2 times sine of theta 2. Okay, and what is theta 2? So let's say 90 minus theta 1 multiplied by cos of 90 minus theta 1, okay, divided by g. And then you know what is sine of 90 minus theta? It is cos theta. What is cos of 90 minus theta? It is sine theta. So cos theta times sine theta, okay, again you get the same thing, right? So this cos of 90 minus theta 1 becomes cos of 90 minus theta 1 becomes sine of theta 1, and sine of 90 minus theta 1 becomes cos of theta 1, right? So this is cos theta 1 and this is sine theta 1. So if you multiply that, you get the same thing, right? So this is clear? Yes, no? Okay, good. So just remember those two cases. If sum of two angles of projection is 180 degrees, then R is in opposite direction. It's equal and in opposite direction of point of projection. And if sum is 90 degrees, then it's equal, R is equal, and it is on the same side. Okay, very simple. All right, let's see next one. For an object thrown at 45 degree to the horizontal, the maximum height h on the horizontal and the horizontal range are related as. So this is very simple. Anyone? Yeah, it's option C. Right, very good, Yamini. So we should always remember that tan theta is equal to, yes, it's option C. Tan theta is equal to 4h divided by r. Tan theta is equal to 4h divided by r, and therefore this is tan of 45 degrees, which is 1. Okay, so 1 is equal to 4h by r, means r is equal to 4h. So it's option C. Okay, let's see next one. A body is projected horizontally from the top of a tower with a velocity of 10 meters per second. If it hits the ground at an angle of 45 degrees, then the vertical component of velocity when it hits the ground in meters per second is. Body is projected from top of a tower with a velocity of 10 meters per second. Okay, so body is projected from top of a tower with a velocity of 10 meters per second. Okay, it's projected horizontally, right? So body is projected horizontally like this. So it will take a path like this, something like this, and it will fall on the ground. Okay, so it falls on the ground. So how high is this tower? What is given? Okay, that thing is not given. It hits the ground at 45 degrees. This is given. Okay, who can tell me? It hits the ground at 45 degrees. Let's say something like this. Yes, who can tell me this? This angle is 45 degrees. Okay, its velocity is directed at 45 degrees. What does it mean? So velocity is directed at 45 degrees. This is velocity. This angle is 45 degrees. So what will be Vx? Vx is equal to V cos 45. Option A. No, V cos 45. Okay, let me check. V cos of 45. And what will be Vy? Vy is also equal to V cos 45. Right? So both of them are equal, and it is projected horizontally from the top of a tower with the velocity of 10 meters per second. So what is Ux? Ux is equal to 10 meters per second. So we know that in projectile motion, the horizontal component of velocity remains constant. That means Vx is equal to Ux only, right? The horizontal component of velocity was 10 meters per second and it will remain 10 meters per second. So Vx is equal to ux. Okay, Vx is equal to ux. But then you have cos of 45 and sine of 45. Okay, this thing will be V sine of 45, but sine and cos of 45 degrees is 1 by root 2 and 1 by root 2 only, so that is equal. Okay, so Vy is equal to Vx and Vx is equal to ux, means Vy is equal to what? Ux. So what was initial velocity? 10 meters per second. So vertical component of the final velocity will also be equal to 10 meters per second. Is this thing clear? Everyone? Selva Kumar, Purna?
Clear, sir.
Purna, is it clear? Okay, good. Right? So always remember that horizontal component of velocity remains constant, and now if velocity is directed at 45 degrees, means horizontal and vertical components are equal. Horizontal component is constant, that means it is same as that of velocity of projection because it was projected horizontally. So that was 10 meters per second, and here horizontal and vertical components are equal, that means vertical component is equal to also equal to 10 meters per second, right? Okay, good. Simple question if we remember these facts. Okay, all right, let's see next one. A body is projected with an angle of theta. The maximum height reached is h. If the time of flight is 4 seconds and g is 10 meters per second, then the value of h is. Okay, tell me. A body is projected with an angle of theta. The maximum height reached is h. If the time of flight is 4 seconds and g is 10 meters per second square, then the value of h is. Anyone? Option A. Okay, let us check. So what is h? Alright, how did you find Yamini? Theta value. Okay. Alright, let's see. So see, when you throw a ball, let's say upwards, okay, so it will go to some height and come back, right? So now if you just think about the vertical direction, okay, vertical component of its motion, then it goes to some height and to come back from there to the ground, what distance does it cover? The distance is equal to h. And what's the relation between this h and the time that it takes to reach the ground? It is half of g into t square. What is this time? So this t will be equal to time of descent, right? Time of descent. So that is t by 2, capital T by 2. So that is 4 by 2, right? Time of flight is 4, means time of descent is 2. So you got 2 seconds. So then you have half of g is 10 multiplied by 2 square. Okay. So that is equal to what? 20. So answer is 20 meters. Yeah, it's option B. Right? This is clear, everyone? Okay. Is this formula applicable? Is it applicable only when we drop an object, or is it applicable everywhere? It is applicable everywhere, right? you can always consider only the vertical component of motion. Okay, so at whatever angle you project it, you can always consider only the vertical component of motion. So what is displacement in vertical direction? If you just drop a ball from maximum height, it is half of gt square, right? So you drop a ball or you throw it horizontally. Okay, even if you throw it horizontally, what will happen? It will cover same height, right? It will cover same height. So r will be different, but what about h? H will be always equal, right? So you can always use this formula. Okay, this thing is clear, Indusha?
Yes, sir.
Okay, good. All right, let's see next one. The velocity of projection at an initial point A is, the velocity of projection at an initial point A is 2 I cap plus 3 j cap. Its velocity in meters per second at point B is, tell me, and this is from NEET. Okay, is I guess 21 or something like that. It is option C, right? Very good. Okay, remember everyone, see, we had seen this, that u bar, the initial velocity, can be written as ux into I cap plus uy times j cap, and v bar is suppose the final velocity at point B, so that is vx into I cap plus vy into j cap. So we had seen that this angle is theta, okay, and this angle will also be equal to theta, this angle is also equal to theta, but then at this point, it's going in this direction. Okay, so this angle is the final angle you can say, or the angle that the final velocity makes, right, with the horizontal. So this angle is also equal to theta because it's vertically opposite. So initial angle of projection and final angle, okay, with which it hits the ground, they are equal, but they are just in opposite direction, right? So therefore ux is equal to what? U cos theta. Okay, ux is u cos theta, so it will remain same because cos of minus theta is equal to cos of theta. But what about the sin theta? Uy is u sin theta. What will be vy? It will, in magnitude, it will be also equal to what? Uy, but you know that sine of minus theta is equal to what? Minus sin theta, and that's why direction wise it's opposite. Okay, magnitude wise it is same as that of uy, but direction wise it's opposite. Okay, this thing is clear, and that's why this thing can be written as, now we need to remember this thing. We can of course solve this, but we need to remember that vx is equal to ux, it's ux into I cap, and vy becomes what? Minus of uy. This is minus of uy, minus of uy times j cap. So what was this thing? 2 plus 3, right? I mean 2 I cap plus 3 j cap. Okay, so this thing will become 2 I cap minus 3 j cap, right? Okay, very good. So just remember this thing as a fact. All right, let's see next one. An aeroplane is flying horizontally with a velocity of 600 kilometers per hour and the height of 1960 meters. When it is vertically above the point A on the ground, a bomb is released from it. The bomb strikes the ground at point B. The distance AB is, tell me. An aeroplane is flying horizontally, okay, and with velocity of this much, and the height at which it is flying, it's 1960 meters. So let's suppose this is an aeroplane, okay, high-tech one. Might look like a fish, I don't know. All right, so it drops a bomb. It drops a bomb. It doesn't drop. It throws. Yeah, it drops a bomb. But since it has some velocity, bomb will also have some velocity, right? Same velocity as that of the aeroplane, and therefore, suppose bomb goes like this. Okay. So the aeroplane is above point A on the ground. It is above point A on the ground, and the bomb, it falls at point B. This is point A, this is point B. So now tell me, what should we do? So this height is given. H is equal to what? 1960 meters. We want to calculate this distance AB. What is given? It's the horizontal velocity. It's flying horizontally. So ux is equal to 600 kilometers per hour. That is 600 multiplied by 5 by 18 meters per second. Okay. So is it divisible? Divisible by 6. So 100 times 5 by 3. 500 by 3. Let's keep it like this, meters per second. Right. Then now what we need to find out is this distance. So we can find out the time it takes to fall on the ground, and for that we can always use h is equal to half of gt square, right? So t is just equal to 2h, square root of 2h by g. Okay. If we move this thing on other side, g on other side. Okay. So from one dimensional motion, we remember that t is equal to square root of 2h by g. Okay. Then put the values. So it is 1960 times 2 divided by 9.8. Right. I guess taking 9.8 will be beneficial. Yes. So 9.8 2s are 19.6. Okay. So this is 2 times 100, that is times 2, that is 400. So you get 20 seconds. Okay. So you get t equals to 20 seconds. And then what will be the horizontal range or horizontal distance covered? R is just equal to ux times t. So that is 500 by 3 times 20. How much is that? Okay, so let's do 500 times 10 is 1000. Then you have 2 by 3. So 2/3 are 0.66. Okay, so 666. Oh, some mistake? $600 by this thing is 600 into 6 times 3, so this will be 100. 100 times 5 is 500. 500 by 3, that seems correct. Then you have twice h by g. Okay, t is equal to square root of 2h by g. Then 1960 19.60 divided by 9.8 is 2. 2 times 100 times 2, 400. Can you spot any calculation mistake in this? Anyone? Last step, this one. So 1000 times 10 by 3. Oh yeah, it will be 10 by 3, no? Oh, correct, I'm sorry. So it will be 10,000 divided by 3, right? So that is 3333 meters. So that means 3.3 kilometers. So that's the answer. Okay, so it is option D. Right. So this thing is clear. Solution. Okay, so while you are telling the calculation mistakes and all, you should speak up, no, at least at that time, because I am trying to figure out what's the mistake and you are commenting, right? I mean, you are texting, so I am seeing on my tab. Okay, so my laptop screen is not visible at that time, right? Anyways, so this thing is clear, everyone. I mean this thing. Okay, good. Then let's see next one. An arrow is shot into air, its range is 200 meters and its time of flight is 5 seconds. If g is 10 meters per second square, then the horizontal component of velocity of the arrow is. Okay, so arrow is shot into air, range is 200 meters and time of flight is 5 seconds. Then what is the horizontal component of velocity? Okay, tell me. You cannot get question simpler than this. Yes. What is horizontal component of velocity? This is the question. Range is given. Okay, time of flight is given. So you know that range is just equal to ux times time of flight. So what is ux? Just range divided by time of flight. Right, what is range? 200. What is time of flight? 5. 200 by 5. What's that? 40. 40 meters per second. This is the answer. Okay. This one is very, very simple. Right? Is there a doubt in this? Anyone? Selva Kumar, is there a doubt in this?
No, sir.
Okay, good. Let's see next one. The horizontal range and maximum height of a projectile are equal. The angle of projection of the projectile is. So we know tan theta is equal to what? 4h by r. R and h are equal, so you can just cancel them out. So tan theta is 4 and theta equals to what? Tan inverse of 4. Right? So again, a very simple question. This is also from NEET, earlier NEET, that was called AIPMT. Okay, let's see next one. A person can throw a stone to maximum height h meter vertically, okay, then maximum distance to which it can be thrown horizontally by the same person is. Tell me. So what is h if you throw a ball vertically or a stone vertically? Then h is just equal to what? U square by 2g. So tell me, to what distance can it be thrown horizontally? Option C, 2h. Okay, others? Anybody else? So you have r equals to u square sine 2 theta by g. So what is r max? So sine 2 theta becomes 1, so it is just u square by g, right? But h is u square divided by 2g, means this is half of r max, right? So this is 2 times of, I can say, u square by 2g, okay, or it is 2 times of h. This is very simple, right? Okay, good. So let's see next one. The height y and the distance x along the horizontal plane of projectile on a certain planet. Okay, so they are going on different planet with no surrounding atmosphere. So this is also given, there is no atmosphere. Are given by y equals to 8t minus 5t square and x equal to 6t, where t is in seconds. The velocity with which the projectile is projected is. Okay, now you tell me what to do. This is little good question. Anyone? Okay, so what you need to do here is just compare it. So x is equal to 16, no? So just compare this thing with x is equal to ux times t. So Nikita is saying it's option A. Let's check. It is not definitely not option A. X is equal to ux times t, and you have y is equal to 8t minus 5t square. So compare this with y is equal to uy times t minus half of gt square. Okay, so what is g on earth? Is 10. 10 by 2 is 5, so it is no other planet but it is earth only, right? Or a planet which is similar to earth, because g there is also 10. Okay, all right. So what is uy? So from this you get ux is equal to 6. Comparing these two, you get ux equal to 6 meters per second, and comparing these two, you get ui equals to 8. Ui equals to 8 meters per second, right? So then what is the initial velocity of projection? So u is just equal to, we know it's square root of ux square plus uy square, because u is ux times I cap plus ui times j cap, right? U bar is equal to ux into I cap plus ui times j cap. Okay, so it is 6 I cap plus 8 j cap, but we want its magnitude. Okay, so if answer is given in meters per second, that is not ux or uy, it is the magnitude. So that is square root of ux square plus uy square. That means square root of 6 square plus 8 square. Okay, so 36 plus 64, so that is 100. Okay, So square root of 100 is 10 meters per second. This is the answer. Right? Okay, good. So again, this question is also not difficult. Right? Anybody from Karnataka? I guess Yamini is from Karnataka, no?
Yes, sir.
Okay, so this is from KCET. Okay, little good question on projectile motion, but it's from Karnataka. Okay, CET. That is engineering exam. All right, let's see next one. The horizontal range of a projectile fired at an angle of 15 degrees is 50 meters. If it is fired with the same speed at an angle of 45 degrees, its range will be. The horizontal range of a projectile fired at an angle of 15 degrees is 50. So you know R is equal to U square sine 2 theta divided by G. Right. So you fire it at same speed at an angle of 45 degrees. So speed is same, G is constant, that means R is directly proportional to sine of 2 theta. Okay, so that's very simple. Then you have R2 by R1 is equal to sine 2 theta 2 divided by sine 2 theta 1, sine of 2 theta 1. So that is sine of 2 theta 2. So theta 2 is 45 degrees, means sine of 90 degrees divided by sine of 2 theta 1, sine of 15 times 2 is 30 degrees. Sine 90 is 1, sine 30 is half. So you move that 2 in the numerator. So R2 by R1 is 2, means R2 is equal to 2 times R1. So R1 was 50, therefore R2 is 100. R2 is 100 meters. Right, this is simple. Okay, all right, good. So this proportionality, this is the biggest tool that you can have in solving physics problems. Okay, proportionality is the biggest thing that you can do. I mean, it's very simple to do. So if you have some formula, like here also it's U square by G, one is increased by factor of 2, one is decreased by factor of 2, okay, something like that. Then you should see R is proportional to U square, it's inversely proportional to, here it is G only, but some other factor is there, okay, then it's inversely proportional to something else. Then what should we do? So if you increase this thing, this is made twice, U is made twice, then what will happen? R will become 4 times because it is directly proportional to its square. Okay, if it is inversely proportional to something, then if it is made half, then what will happen? Again it will become twice because it's inversely proportional. Okay, so that is comparison. Okay, proportionality and comparison. So these things you should exploit these things to get the faster results. Okay, all right, let's see next one. For a projectile, range square is 48 times of maximum height square obtained. Find the angle of projection. Tell me, R square is equal to 48 times of h square. So here what should we do? Again we know tan theta equals to 4h by r, right? So what is r? R is equal to 4h by tan theta, or should we do 4h? 4h is equal to r tan theta. So here we need to h square is there, no? Okay, so here I can write this thing as 3 times 16 times h square. Okay, 16 3s are 48. So then this is 4h square, 16h square is 4h square, right? So 4h square means it is 3 times of r tan theta square, or r square tan square theta, and then that r square will get cancelled out. So then you have tan of theta square, tan square theta is 1 by 3, and therefore tan theta is 1 by root 3. So what's the angle? For which angle is the tan theta 1 by root 3? $30, no? Yes, no? So the answer is 30 degrees. Right, this is clear. Yes, no? Okay. Alright, let's see next one. A projectile can have same range r for two angles of projection if t1 and t2 be the times of lights in two cases, then the product of two times of lights is proportional to. It has two angles of projection, t1 and t2. T1 and t2 are the times of light in those two cases. Okay, a projectile can have same range r for two angles of projection. So what are those two angles? So first angle is, you can say, theta 1. So second angle must be equal to what? Tell me. Anyone? You want same range, so second angle should be what should be the second angle? -90 minus theta. Good. So that should be 90 minus theta 1, right? So for first one, time of light is 2u sin theta 1 by g. For second one, it is 2u sin of theta 2. Theta 2 is 90 minus theta 1 by g. And then we know what is sine of 90 minus theta? It is cos of theta. So therefore T2 is equal to, then you have T2 is equal to 2u sine of 90 minus theta is cos of theta. So it is cos of theta 1 by g. And then they say that product of two times, product of T1 and T2, just multiply them. So T1 T2 is equal to 2u sin theta 1 by g multiplied by, it is 2u cos of theta 1 by g. So that is, you have two, so see, you have sin theta 1 cos theta 1 times 2, is that is sin 2 theta, and then you have 2 times u is u square, okay, u times u is u square, 2 sin theta 1 cos theta 1, so that is sine of 2 theta, or let's say sine of 2 theta 1 divided by, you have g square. Okay, so that I can write like this, g times g. So u square sine of 2 theta 1 by g, this is r, and t1 t2 is 2 by g, this is my g, okay, this is not 9, okay, this is my g, this thing times r. So then tell me, T1 T2, they say it's proportional to, it's proportional to what? It's proportional to r, right? Because 2 by g is a constant, that's 1 by 5, right? Simple? Yes, no? Right, it's simple. Okay, let's see next one. The maximum height attained by a projectile is increased by 5%. So h is increased by 5%. Keeping the angle of projection constant, what is the percentage increase in horizontal range? Okay, tell me. So the formula of h is what? It is u square sine square theta by 2g, and formula for r is u square sine 2 theta by g. So h is increased by 5%, then what should be increment in r? This is the question. Theta is kept equal. So theta is a constant, g is a constant. What is a variable? U is a variable, and then you know that from our first chapter, delta h by h times 100, this is percentage change in h, it will be equal to 2 times of percentage change in u, right? So this is 5%, means percentage change in u is what? It's 2%. This is 2 times of percentage change in u, right? So what is therefore delta u by u into 100, percentage change in u is 5% by 2, means it's 2%. So delta u by u times 100 is 2%. But h is directly proportional to u square, r is also directly proportional to u square, and there is no other power, right? This is also proportional to u square only. So delta h by h times 100 is equal to delta u by u times 100, 2 times delta u by u times 100, and what will be delta r by r times 100? It is also 2 times of delta u by u times 100. So proportionality is same. So whatever percentage change is there in h, same percentage change will be there in r also, because the proportionality on u, both of h and r is same. Okay, both are directly proportional to u square only. So if there is some change in, some error in u, you can say, or some change in u, small change in u, okay, small percentage change, then in both h and r, percentage change would be what? Twice of that of u, right? Yes, no? So that's why answer is 5%. Okay. Oh, this is 2.5%. Delta u by u into 100 is 2.5%. It's 5% by 2. Okay. So this thing delta r by r into 100 is 2 times of 2.5%. But we don't need to do all this maths. So if h is proportional to u square, then percentage change in h is what? 5%. Then change in u must be what? This is equal to 2 times change in u. Okay, percentage change in u. So percentage change in u is 2.5. Okay, and then because its proportionality is same, okay, for h as well as r also, therefore what will be percentage change in r? It will be same as that of h. Okay, we don't even need to write down anything. We can do that all in mind, right? Okay, so our mind should run that way. Okay, so this thing is clear? Yes, no?
Yes, sir.
Okay, good. All right, let's see next. A ball is projected from the ground at an angle of theta with the horizontal. After 1 second, it is moving at an angle of 45 degree. So once they say 45 degree, okay, once they say 45 degree, Vx and Vy are equal. Okay, so at t equals to 1 second, Vx is equal to Vy, right? And after 2 seconds with the horizontal, and after 2 seconds it's moving horizontally, and once they say horizontally, that means what happens is Vy becomes 0. Okay, what is the velocity of projection of the ball? Okay, so let's say V2y equals to 0. This is at t equals to 2 seconds, at t equal to 2 seconds. So this is maximum height, right? This is the maximum height. Okay, Vy is 0, and then what is h? So they have asked about this thing, what is the velocity of projection? So Vy is 0, we can find out what is Uy from this, right? So Vy is 0, so Vy is equal to what? You can see Uy minus Gt. Okay, this thing is 0, that means it is Uy minus, let's take G equals to 10, 10 times what is t? It is 2 seconds. So 10 times 2 is 20, so Uy is equal to 20. So you got Uy equals to 20. Okay, you got Uy 20 meters per second. And then at 1 second, what will happen? Vy is equal to Uy minus Gt. So that is 20 minus G is 10, 10 times 1. So 10 times 1 is 10. So Vy is equal to 10. Okay, meters per second. So now this Vy is equal to Vx. Okay, because at that time the projectile is moving at 45 degrees. So when it is 45, so V is directed at 45, means Vx and Vy are equal. Okay, so Vx is equal to 10 meters per second. But then you know that Vx is just equal to Ux because it remains constant, it never changes. So Ux is equal to 10 meters per second. And then you can very easily find out what is the velocity of projection. So what is the velocity of projection? U is equal to square root of Ux square plus Uy square, that is equal to square root of 10 square plus 20 square. Okay, so that is 10 square plus 20 square, so that's 500, square root of that. Okay, so 100 times 5, square root of 100 is 10. You have U equals to 10 root 5 meters per second, right? So it is option C. This one is clear. We are going to talk about the circular motion. Okay, so now what is circular motion? So suppose there is an object which moves along circumference of circle, its motion is circular motion, right? So there are few basic definitions regarding this circular motion. So first is angular displacement. Now what is angular displacement? It's just like our linear displacement. Okay, so here see, in case of linear displacement, we take shortest distance between start point and end point. Now what is the angular displacement? So suppose you have this object and it is moving along circumference of this circle. So when it moves from this point A to the point B, okay, its trajectory or its path is an arc of the circle, and that arc makes some angle at the center. It is known as angular displacement. Okay, as simple as that. It moves along the circle, then its path, if you take that arc, okay, it makes some angle at the center. It is known as angular displacement. Now this is displacement, means it's a vector quantity, right? So it will have magnitude as well as direction. Okay, so it has got magnitude as well as direction. So now magnitude is just the magnitude of this angle. So we know how to measure the angle in radians, right? So it is the length of this arc divided by radius. Okay, so we know theta is equal to what? Length of arc, that is length of this arc AB. Okay, S divided by R. R is the radius, right? Now how to find out its direction? So there is a rule to find out its direction. It is called as right hand thumb rule. Okay, so what is right hand thumb rule? So take your right hand, curl the fingers of your right hand in direction of motion of this particle along the circumference of circle and stretch your thumb. So your stretched thumb will show the direction of angular displacement. This thing is clear? Yes, no? everyone? Okay, so now tell me what will be the direction of angular displacement of this particle. It is moving in anti-clockwise sense in this circle. Yes, into the plane or outside the plane of your screen? Tell me. Just apply right hand thumb rule, curl the fingers of your right hand in direction of motion of this particle and stretch your thumb. Tell me, is it into the plane or outside the plane? It is outside the plane of the screen. Yeah, very good. So the direction is outside the plane of your screen. Okay, right now. Alright, so this is angular displacement, and just like we define the linear velocity, which is displacement divided by time, we define angular velocity. Now this is average angular velocity, so it is just total angular displacement divided by time. Okay, so it is angular displacement divided by time. So omega, this letter is called as omega. It looks like W, right? There is no difference between omega and W. Okay, but we call it as omega. Angular velocity, it is denoted by letter omega, right? It is a little bit curly W, but some people just like W like this. Okay, so practically there is no difference. So this is omega. Omega is angular displacement, angular velocity. How do we define it? Angular displacement divided by time, and I have put suffix AV, right? AV, to show that it's an average angular velocity. So what is average angular velocity? Angular displacement divided by time. What would be its unit? So unit of an angle, SI unit is radians. So unit of angular displacement is radians. Therefore unit of angular velocity would be radian for this angle divided by unit of time, that is second. So unit is radians per second, right? That's very, very simple. After that, next is the instantaneous angular velocity. So we know how to find out an instantaneous linear velocity. What is that? It's just derivative of linear displacement with respect to time, or you can say it's derivative of position with respect to time. So just like that, we have instantaneous angular velocity, omega bar. So here I haven't put the suffix average, okay, AV. So omega bar is equal to what? Just d theta bar by dt. Okay, rate of change of angular displacement with respect to time. So this thing is clear? Yes, no? Right, everyone? Okay, now tell me what will be its direction? What will be the direction of angular velocity? Same as that of angular displacement, right? Direction of angular velocity will be same as that of angular displacement. Okay, good. Then next let's talk about the angular acceleration. Now what is linear acceleration? Change in velocity divided by time. So what would be angular acceleration? It is just change in angular velocity divided by time. So suppose omega naught is initial angular velocity at time t equal to 0. Omega t is angular velocity at time t. Okay, so what would be average angular acceleration? So it is just omega t, okay, omega t bar minus omega naught bar divided by time. So this is change in angular velocity divided by time, and unit is just radian per second square, just like our acceleration has, linear acceleration has unit of meter per second square, right? So this is average angular acceleration. Okay, and if you want instantaneous value, so every time you want an instantaneous value of any quantity, what do you take? You take a derivative, right? So alpha bar, would be what? Derivative of omega bar with respect to time. Okay, d omega bar by dt. Okay, right? So now tell me what would be its direction. Average angular acceleration or instantaneous angular acceleration, what would be its direction? Tell me. Anyone? Is it same as that of angular displacement or angular velocity or something else? It's very simple. See, if angular velocity is increasing, the acceleration is in same direction of angular velocity. If it is decreasing, means acceleration, the angular acceleration is in opposite direction of angular velocity, right? If angular velocity is increasing, that means your object is moving faster. Okay, its speed is increasing, it covers those angle rapidly, right? Then what will happen? The angular acceleration is in same direction as that of angular velocity. But if the angular velocity is decreasing, then it is in opposite direction. This thing is clear? Yes, no? Okay, Nikita, is it clear? All right, good. So then, I have written it over here. If omega t is greater than omega naught, the angular acceleration is in same direction of omega, otherwise it's in opposite direction, right? So that's very simple. Now see, what is uniform circular motion? So if speed of an object remains constant in the circular motion, we call it as a uniform circular motion. Okay, speed remains constant, not the velocity. Okay, speed and velocity are different things. So what is speed? It is magnitude of velocity. Okay, what is speed? It is magnitude of velocity, right? So then the time period, or it is also called as just period or periodic time. Okay, different names. So time period of an object performing circular motion is just the time taken by the object to complete one revolution along the circumference of circle. Okay, time period is time taken by an object to complete one revolution along the circumference of circle. Very simple. Then let's talk about the relation between the linear speed and angular speed. Okay, so all these things are very simple. See, we have defined angular speed. What's that? Omega is angular speed. So now it is angle covered per unit time. So now in one revolution, how much of angle will be covered? How much of an angle will be covered? It's 2 pi, right? In radians, in one revolution, angle covered would be 2 pi. So you have angular speed is equal to what? 2 pi divided by t, right? Then you have linear speed. So what is linear speed? The distance covered in one revolution divided by time taken. So that is, distance covered is circumference of circle, 2 pi r, divided by time taken is capital T. Okay, that is time period. Time period is denoted by capital T. So linear speed is equal to 2 pi r divided by capital T. Angular speed is 2 pi divided by capital T. So what's the relation between them? This linear speed v is equal to what? R multiplied by 2 pi by t, that is angular speed. So v is equal to r times omega. Okay, v is equal to r times omega. This is very simple, right? Okay, good. Then next we define frequency. So what is frequency? So number of revolutions performed by an object per unit time. Okay, so number of revolutions performed by an object per unit time is the frequency. It is just reciprocal of time period. Okay, frequency is just reciprocal of time period. Now frequency, you can denote it by n, you can denote it by nu, you can denote it by f, different letters. Okay, so now you have omega equals to 2 pi divided by t, right? Omega is equal to 2 pi by t, and 1 upon t is frequency. So therefore omega, there is another formula. So 1 by t is frequency, 1 by t is n, therefore omega becomes 2 pi n, right? Therefore omega becomes what? It becomes 2 pi n, right? That's very simple. Okay, so we are starting from very basic things. All right, after that, now let's understand some concepts. Okay, so these were also so whatever we saw till now are very basic concepts. Okay, so now let's talk about the tangential acceleration. So what is tangential acceleration? So in circular motion, an object revolves around circumference of circle. Okay, you can take an example of a stone tied to a string. Okay, nobody does that nowadays, but suppose you take a stone tied to a string and you whirl it like this in a circle. So now suppose you release it at this point. Okay, so let me suppose you are revolving it like this, you release it at this point. What will happen? It will come like this towards you. Okay, you release it here, then it will go in this direction. You release it here, it will go in this direction. You release it backwards, then it will go in that direction. Okay, in what direction? It always goes along the tangent, right? It always goes along the tangent, and that tells you that in circular motion the velocity is directed tangential. Okay, so for an example, this is that stone which is tied to a string and you whirled it in this circle. Okay, so at this point its velocity will be directed like this. At point B the velocity is directed like this. At point C the velocity is directed like this, and at point D the velocity is directed like this. So now velocity is directed along the tangent, that's why it is called as tangential velocity. And if there is change in the magnitude of this tangential velocity, okay, earlier suppose it was 1 meters per second, now it's 2 meters per second, then there would be acceleration, right, because of change in magnitude of this tangential velocity. Okay, so tangential acceleration is the acceleration in circular motion due to the change in magnitude of velocity. Okay, this is because of change in magnitude of velocity. So now how to find it out? So simply the way we find out acceleration, suppose v1 is the speed at time t1 and v2 is the speed at time t2, then what is tangential acceleration? It is just v2 minus v1, the change in speed, divided by change in time. Okay, so v2 minus v1 divided by t2 minus t1, right? And then we just saw that v can be written as r times omega, right? So v1 is equal to, I can say, r times omega 1, okay, angular speed at time t1. v2 is equal to r times omega 2, angular speed at time t2 is omega 2. And if you just substitute that in this formula, then what do you get? R you can take common, it's omega 2 minus omega 1 divided by t2 minus t1. And what is this thing? So omega 2 minus omega 1 divided by t2 minus t1 is angular acceleration, that we denote by alpha, right? So the tangential acceleration is equal to r times the angular acceleration. The tangential acceleration is equal to r times angular acceleration. This thing is clear, everyone? Yes, no? Right, tangential acceleration is r times angular acceleration. So there are two things to be remembered. It is because of change in what? The magnitude of velocity. Okay, this is one thing, right? And second thing is it is r times angular acceleration. So if angular acceleration is 0, means the object moves with constant angular speed. That is, object moves with constant linear speed. Okay, right? Both are equal or equivalent, you can say. If angular speed is constant, if omega is constant, means v is also constant. Okay, so if object moves with constant speed, then what will be the tangential acceleration? It will be 0, right? If there is no change in speed, what will be tangential acceleration? It will be 0. Yes, no? Right. So this is one type of acceleration that's there in circular motion. There is another type of acceleration too, and it is called as centripetal acceleration. Okay, it is known as what? Centripetal acceleration. So now remember this thing, this acceleration in circular motion, this is the acceleration in circular motion due to change in direction of velocity. Okay, so tangential acceleration will be there if there is change in magnitude of velocity. The centripetal acceleration is there due to change in direction of velocity. Okay, and in circular motion the direction of velocity is never constant, right? So for an example, suppose the speed is constant. Okay, so this is the speed at point A, let's say VA. So if I want velocity, it is directed like this. Okay, so this thing will be VA bar. Now at point B, when object moves from A to B, if speed remains constant, speed can remain constant, right? But its velocity is directed like this. Okay, so this is VB bar, right? And then this vector is VA bar, this vector is VB bar. You can never say that this vector and this vector is equal, right? They are different because they are directed in different directions. Okay, their magnitude can be equal, their magnitude is equal. In fact, if the speed is constant, then the length of this vector VA bar is equal to length of VB bar. Okay, so that shows that speed is constant, magnitude of velocity is constant, but their direction is different. So if direction is different, means the velocity is changing, and the acceleration because of this change in direction of velocity, it's called as centripetal acceleration. So this thing is clear. Okay, what's the cause of tangential acceleration? What's the cause of centripetal acceleration? Okay, good. So centripetal acceleration is due to change in direction of velocity. So now this is always present in circular motion. So we'll take an example of uniform circular motion, because this acceleration is because of what? Change in direction only. Now suppose suppose this is your object, it's at point A, then velocity is directed like this. When it moves from A to B, okay, when it moves from A to B, what will happen? Its velocity at point B is directed like this, and this is VB bar. I want to subtract VA bar from that to find out change in velocity. So what I do is I take this VA bar, I put it at this point, and using triangle law of vectors addition or subtraction, I subtract it. So then this is my VA bar, I have taken it from here and put it at point B. Okay, so this is VA bar, I want to subtract it from VB bar. So I see that VA bar plus this vector, okay, will give me what? VB bar. That means this vector is delta V bar, it's VB bar minus VA bar. This thing is clear? Yes, no? Right? Delta V bar is equal to VB bar minus VA bar. Okay. So now suppose your object moves through an angle of delta theta when it goes from A to B. So now we know what is delta theta. It's equal to arc length divided by radius. Okay, it is equal to the length of the arc divided by radius, right? This is clear till this point. All right, so this is just a definition, right? So then for very small angle, I can say arc length is just equal to, so see, your object was here, so this is position vector at point A, when object is at point A. When object moves from here to here, the position vector becomes this RB bar. So what is change in position, or what is displacement? This is the displacement, okay? And for very small displacement, you can say that arc length and this displacement, they will be almost identical, okay, almost equal, right? So is that digestible? Yes, no? All right, good. So for, or let me just explain it. Okay, so this is a circle. Suppose the object moves from this point A to point B, and now I have taken small displacement, okay? So this is point A, this is point B, and now what would be, this is the distance covered, right, which is equal to length of the arc, and what would be the displacement? It's the line joining point A and B, okay, and this displacement is small, so length of this line and this arc, they are almost equal. Yes, no? Okay, if I zoom out, you cannot even differentiate between the line AB and arc AB. Yes, no? Okay, good. So for small displacements or for small angle, the length of arc and length of the linear displacement, they are almost equal, right? And then using that, I can write the delta theta is just equal to delta r divided by r. And then one more thing is, see over here, now how can you find out this delta theta? Delta theta is delta r divided by r, okay? So one more thing is, if you see at this triangle, okay, this side and this side, they are equal, and this angle is delta theta, right? So now velocity is perpendicular to the radius, okay, because it's in tangential direction. So now if you move the radius by an angle theta, the velocity will also move with an angle theta, right? The angle that we have taken is delta theta. So if you move the radius by an angle delta theta, the velocity will also move, the perpendicular will also move by an angle delta theta. So that means if you think about this triangle and this triangle, they are similar. How? By, if we go mathematical, it is SAS test, okay? So this side and this side, length of those two sides would be equal, because the velocity has constant magnitude, okay? So VA bar's magnitude and VB bar's magnitude is equal, and then this angle would be delta theta. So two sides are equal, angle between them is delta theta, right? So then if you take ratio of this side to this side in this triangle, what you have taken is delta r divided by r, it gives you delta theta. So here delta theta can be found by taking delta v by v, okay, can be found by taking delta v by v. This thing is clear? Yes, no? All right, good. So then delta theta can be also written as delta v by v. So then you can take this v on other side, so delta v is equal to, you can say, v times delta theta, okay, and then you just divide both sides of this equation by delta t. So you get, and apply this limit delta t tends to 0, okay. So you get instantaneous acceleration, right? So instantaneous acceleration is just equal to limit delta t tends to 0 v times delta theta by delta t. So what is delta theta by delta t? It is omega, change in angle or change in angular displacement you can say, divided by time. So that is omega, and therefore you get this side is delta v by delta t, means it is acceleration. It is equal to v multiplied by delta theta by delta t, so that is omega. Okay, so this acceleration is because of which thing? It's because of change in direction of velocity, and that's why we call it as centripetal acceleration. Okay, this is not the reason. So the reason is this acceleration would be directed along radius and towards center. This acceleration would be directed along the radius and towards the center of the circle. That's why it is called as centripetal acceleration. But where does it come from, the centripetal acceleration? Because of change in direction of velocity. Okay, so I am calling it centripetal acceleration. So I put suffix ac, suffix c, okay, a suffix c, c for centripetal, right, and it is equal to v multiplied by delta theta by delta t is omega. So this thing is clear. Is this formula clear for centripetal acceleration, everyone? All right, very good. So then you can use the formula omega is v by r. If you substitute that in this formula, then you get v multiplied by omega is v by r. So that is v times v by r. So v square by r. And if you substitute that v is equal to r omega, you get another formula, that is r times omega, that is omega square. So you have three formulae for centripetal acceleration. One is v times omega, second one is v square by r, third one is r omega square, and all three you need to remember, right? Okay, any confusion in this? Tell me, because this is a very, very important point. Okay, it's there in circular motion, it's there in gravitation, it's there in rotational motion. Right, no confusion. Okay, all right, so this is the scalar form of the centripetal acceleration, and now I'm not proving it, I'm just telling it to you that its direction is along radius and towards the center. Okay, so if you take radius vector anywhere, let's say at this point, it will start, radius vector is the position vector of the particle in circular motion. So it starts at the origin, which you can call it as center of the circle. So center of circle, okay, and it's directed towards the position of particle. So this is along radius away from center, right? It's along radius away from center, the radius vector, and your centripetal acceleration is opposite to that, and that's why, see, you have centripetal acceleration equals to r omega square, but then it's directed opposite to r bar, and that's why I have put this negative sign. Okay, we need to put this negative sign. So AC bar is equal to minus of omega square r bar. AC bar is equal to minus of v square by r into r cap, and AC bar is equal to omega bar cross v bar. It's not v bar cross omega bar. This thing you will need to remember. Okay. Right. So then there are some similar relations which I am going to write now. So similar relations are the relation between linear quantities and angular quantities. So vector relations between the linear quantities and angular quantities, that's very, very simple. So see, if object moves along the circumference of circle, and suppose it goes from a point A to point B. Okay, and this angle is very small angle. The angle is delta theta. Object is moving from point A to point B, right? So length of the arc is suppose delta s, it's very small. So angular displacement is small, this arc length is small, and we had seen that delta s is equal to what? R multiplied by delta theta. So this is scalar form, and in vector form this delta s bar, okay, if you take very small value of that, it will be directed along the tangent. Okay, it's directed along tangent. This is linear displacement in very small time. This is linear displacement. I will write disp, okay, for linear displacement in very small time, in delta t tends to 0. Okay, very small time, right? So it is directed along the tangent. You can see that in very small time the object is always moving along the tangent, right? So then now what's the relation between this delta s bar, which is a vector quantity, r bar at this point, which is a vector quantity, and delta theta bar, which is also a vector quantity? So relation between them is delta s bar is equal to delta theta bar cross r bar. So you can check this, okay, using right hand thumb rule, right? Okay, so now we haven't seen what is the cross product of vectors till now, but I'm just stating the relations because we are talking about the circular motion, and these relations, they are related to circular motion. So I'm just stating it. So we'll take if we take cross product of two vectors, then we get the resultant is also a vector quantity. Okay, so delta s bar is equal to delta theta bar cross r bar. Then you have v bar is equal to omega bar cross r bar, and then there is another one, that tangential acceleration at bar is equal to alpha bar cross r bar, right? So do you know about the cross product? Yes, no? Okay, if you know, that's good. We are going to see the cross product, okay, when it comes, but these relations, they are related to circular motion. That's why I am stating it here. Okay, so I guess there should be no problem. We just need to remember this or by heart these. Okay, all right. So there is simple trick to remember this. Linear quantity will come first, and then, oh, what did I say? The angular quantity will come first and then followed by the linear quantity. And linear quantity is same thing only, it's r bar only everywhere, right? In these three. Okay, so magnitude wise we remember them, direction wise there will be a cross product. Okay, so delta theta bar, delta s bar is equal to delta theta bar. The angular term will come first, then cross sign followed by the linear term, right? Okay, v is equal to r omega, this is scalar form, but in vector form v bar is equal to omega bar cross r bar, and at bar is equal to what? It is r multiplied by alpha, but in vector form or in scalar form you can write anyway, right? R alpha, alpha r, no problem. But in vector form the angular term will come first followed by cross sign and then the linear term. So similarly here, centripetal acceleration also we have seen it's minus of omega square r bar. Okay, it's minus of v square by r times r cap. So these two tell you that it's directed along radius, but it is towards the center. But radius vector is directed away from center. Okay, it's along the radius but towards center, that's why the negative sign is there. But when you write it as omega times v or v times omega, if you want to write it in vector form, the angular term will come first. Okay, that is omega bar, followed by cross, followed by the linear term. Right? So same theme is there everywhere. This is clear? Yes, no? Okay, because they can ask a question like that sometimes. All right, good. Then here, this should be very clear that omega, the centripetal acceleration, and v, all three are perpendicular to each other. Right? Omega is directed along the axis. What is an axis? If you think about a circle, a straight line passing through the center of the circle and which is perpendicular to the plane, it is known as axis. Okay, axis means for a circle, a straight line passing through the center and perpendicular to circle. If circle is in this plane, circle is like this. What is an axis? A straight line which is perpendicular to this plane and passing through the center. Right? So that is an axis. All right, good. Okay. So if there is any doubt, you can ask me. All right, good. So then we talked about the centripetal acceleration, which is due to the direction, change in direction, and we talked about the tangential acceleration, which is due to change in magnitude of velocity. So there are, if it is uniform circular motion, then there is no tangential acceleration, there is only centripetal acceleration. But in non-uniform circular motion, there will be two accelerations. One is the centripetal acceleration, one is the tangential acceleration, right? And how are they directed? Centripetal acceleration is directed along radius and towards the center. Tangential acceleration is directed like this. Okay, it is directed in tangential direction along the tangent. So what is the total acceleration in non-uniform circular motion? So it is vector sum of these two, vector addition of these two. So if you just apply the parallelogram law of vectors addition, so these two are perpendicular to each other, right? So A bar, you can say it's equal to AC bar. It is also called as radial acceleration because it is along the radius. So it is also written as AR bar, okay, AC bar or AR bar, centripetal acceleration or radial acceleration, okay. And then there is tangential acceleration. So A bar is equal to AC bar plus AT bar, and if you want magnitude of that, then it's just square root of AC square plus AT square, okay. So magnitude of this total acceleration is just square root of the magnitude of centripetal acceleration square plus magnitude of tangential acceleration square. Right? So what is some example of non-uniform circular motion? Non-uniform circular motion, any vertical circular motion is non-uniform. So can you tell me the reason behind that? Anyone? If you take an object, suppose you take a stone, okay, and you whirl it in vertical circle like this, then its motion is non-uniform circular motion. What could be the reason? The reason is gravity, right? Gravity will change the magnitude of velocity. Yes, no? Okay, all right, good. So vertical circular motion is non-uniform circular motion. Okay, then now we have seen what is centripetal acceleration, but then we'll talk about another method because there are problems based upon this thing. Okay, so centripetal acceleration using the calculus method, and this is very simple. Okay, so see, suppose the position vector of an object in circular motion is denoted by r bar, and we just want centripetal acceleration. That means our object is performing uniform circular motion. Okay, it is in uniform circular motion. So this is the position vector of our object at some time t. So suppose our object started from this point. So this point is point A, and it moves to the point B in some time t, right? It moves to the point B in some time t. So while moving, there is some angular displacement. So angular displacement is suppose theta. Okay, so we know what is angular velocity. So angular velocity is omega is theta divided by t, and therefore theta will be equal to what? Omega times t, right? Theta is equal to omega times t. Okay, just take the t on other side. So you got theta equals to omega times t. Okay, so this theta is equal to omega times t. Now what I will do is, this is the position vector of my object in the circular motion. I will just resolve it along two components, one along the x-axis, one along the y-axis. Okay, so I have resolved it along two components. So then after that, so I can write it as rx times I cap plus ry times j cap. Okay, so we have seen the resolution, we know how to do that. So now you tell me what will be rx and ry, which one will be r cos theta, which one will be r sin theta? Resolution.
Rx is r cos theta.
Rx is r cos theta and ry is r sin theta, right? Always remember, through the angle cos component, away from angle sin component, right? So Rx is r cos theta, so r bar is equal to r cos theta into I cap plus r sin theta into j cap. Then theta can be written as what? Omega t. The next step I am doing that. R bar is equal to r cos of omega t multiplied by I cap plus r sin omega t multiplied by j cap, right? So this is my position vector. Now I know change in position with respect to time is velocity. Okay, rate of change of position with respect to time is velocity. So to find out its velocity, what I will do is, I will just take derivative of position vector with respect to time. So dr, change in r, is the displacement, right? The displacement by time is velocity. So then if you do that, you need to take derivative of this thing. So r you can take common, and when you take derivative of cos omega t, so what would be its derivative? Who can tell me? Derivative of cos of omega t with respect to t. Yeah, so derivative of cos is minus sine. Okay, but then, okay, we have seen the method, right, when we discussed about the mathematical methods. So derivative of cos is minus sine. So let me write it here. I want to take derivative of cos of omega t, okay, with respect to t. So derivative of cos is minus sine, so I will just say it's minus sine omega t, but then I am not taking derivative of cos of t, that could be minus sine t. I am taking derivative of cos of omega t. So what I need to do is take derivative of this thing. Okay, this is cos of the bracket, so I will just say it's minus sine of the bracket multiplied by derivative of the bracket. And what's derivative of bracket? That's omega, so I have multiplied by omega. So this is known as chain rule, right? This is called as the chain rule of derivatives. Okay, remember? Yes, no? All right, good. So then take derivative of cos of omega t. So it is omega multiplied by minus sin omega t. Derivative of sin omega t is omega multiplied by cos omega t. Okay, derivative of sin is cos, so cos of omega t, but then multiply by derivative of omega t, that's omega. Okay, so that's why that omega is coming. All right, after that what you can do is you can take its derivative, take derivative of velocity, so you get acceleration. And here, since we have taken omega constant, that means we are talking about the uniform circular motion, right? And because it is uniform circular motion, there will be only one acceleration, that is due to change in direction of velocity, right? So just take derivative of velocity now. So if you take one more derivative of velocity, what happens? The sin omega t, if you take its derivative will be cos omega t multiplied by omega, right? And again derivative of cos omega t is minus sin omega t multiplied by omega. So that multiplied by omega is there, no? We take it outside. We have r times omega multiplied by another omega, which will come from derivatives of the sin and cos term. So you have r times omega square, and the remaining thing is there in this bracket. So that's minus derivative of sin is cos. Okay, minus sin was already there. Minus cos of omega t into I cap. Okay, plus derivative of cos is minus sin. So minus sin omega t into j cap. So what is this thing? If you take minus sin outside and take r inside, okay, it is minus omega square multiplied by r cos omega t into I cap plus r sin omega t into j cap, and this is nothing but your position vector r bar. Okay, this is your position vector r bar. So this thing is clear, everyone? Yes, no? Right, very good. So now what do we need to remember from this derivation? So we need to remember first of all the resolution of this radius vector. Okay, so r bar is equal to r cos omega t into I cap plus r sin omega t into j cap if your object is moving in anti-clockwise sense. So can you tell me, if it is moving in clockwise sense, then what would be what will change here? So depending upon where it is starting from, cos will change to sin, sin will change to cos. There is a problem like that which was there in NEET, we'll see. Okay, but for now let me box this thing. Right, so this is the radius vector or position vector you can say, and given that, or suppose given the circular motion, given the sense of revolution, etc., we should be able to write this vector and we should be able to find its velocity. Okay, this thing is clear? Yes, no? Right, is there a question in this? All right, good. So then there are, just like we have kinematic equations for linear motion, we have kinematic equations for circular motion too. Okay, so just linear quantities will become angular quantities, right? So we have v equals to u plus at. So just similar to that, we have omega, which is final angular velocity at time t, is equal to initial angular velocity plus angular acceleration times t. Change every linear quantity to angular quantity, corresponding angular quantity. So v is final velocity, so in place of that write final angular velocity. Then u is your initial velocity, in place of that write initial angular velocity, and a is acceleration, in place of that write initial angular acceleration. Okay. Similarly, you can say theta for this thing, s is equal to ut plus half of at square. You can say theta is equal to omega naught t plus half of alpha times t square, right? Just change u to omega naught and change a to alpha, and we have v square equals to u square plus 2as. Just like that, omega square is equal to omega naught square plus 2 times a will change to the linear acceleration will change to what? Alpha, angular acceleration, and linear displacement changes to theta, angular displacement. This is clear, everyone? Right? Good. And then if it is uniform, if you have uniform acceleration, then you can say average speed or average velocity. Okay. V average is just equal to what? U plus V divided by 2. Right, we have seen this in straight line motion. So just like that, we have uniform, if we have uniform angular acceleration, then we can say this is uniform angular acceleration, then we can say average angular velocity, let's call it omega average. It's just equal to what? Omega naught plus omega t, or we are writing it as omega here, right, divided by 2. Okay. And then see, omega can be written as 2 pi n then omega can be written as 2 pi n. So everywhere we can say that omega average can be written as what? So let's call this 1. So from 1 I can say what is omega average? So 2 pi multiplied by n average is equal to 2 pi multiplied by n, the final frequency, plus 2 pi multiplied by starting frequency or initial frequency divided by 2. So 2 pi can be cancelled out everywhere. So you get average frequency is equal to n plus n naught divided by 2. So this thing is clear? Yes, no, everyone? Right? And then now we'll see some problems based upon this thing. Okay. All right. So let's see some problems. The angular speed on a flywheel moving with uniform angular acceleration changes from 1200 rpm, rpm means revolutions per minute, to 3120 rpm in 16 seconds. The angular acceleration in radians per second square is. So this is from NEET 2022, very simple question. So what is initial angular speed? It's 1200 rpm, but it is not angular speed, it is initial frequency, right? It's n naught because it is given in terms of revolutions per minute. So it is 1200 rpm and I want to convert it to revolutions per second. So what should I do? divided by 60. Okay, so this is revolutions per minute, right? You have revolutions per minute and per minute. So I want to change it to second. So 1 minute is 60 seconds. So that's why I am dividing by 60, right? Yes, no, this is clear. This is very basic thing, but I want to just make sure that everybody understands, right? So then divide by 10 to numerator denominator, 0 gets cancelled. Okay, we often say it in this way, 0 doesn't get cancelled. What happens is you can divide by 10 numerator denominator. All right, then 120 by 6 is what? 20. So this is equal to 20 RPS. And what is N final one? It's 3120 divided by 60. So that is 312. 5s are 30, then you have 12, so 52. So 52 RPS, right? So you got initial frequency, final frequency, and you want angular acceleration. So what is angular acceleration? Alpha is just equal to omega minus omega naught divided by t, right? And that is, in omega and omega naught you can take 2 pi common. So alpha is just equal to 2 pi multiplied by n minus n naught divided by t. So that is 2 pi, 2 times 3.14 multiplied by, or it's given in terms of pi, no? So let's keep it like that. All right, so let's keep it like that. So 2 times pi, n is 52 minus n naught is 20 divided by time is how many seconds? 16 seconds. So 52 minus 20 is 32. 32 by 16 is 2, right? 2 times 2 is 4. So 4 pi is the answer. Okay, this is clear, everyone? Okay, very good. Let's see next one. See, first we'll see very simple problems. First we'll see some recent problems, right? The angular speed of wheel of a vehicle is increased from 360 rpm to 1200 rpm in 14 seconds. So what is angular acceleration? Its angular acceleration is so this is also very simple question, same as that of previous one. So you have omega 1 equals to 2 pi n1, or let's do this, alpha is equal to what? 2 pi n1, or let's say n minus n naught divided by t. You can directly write down this formula. Then it is 2 pi multiplied by what is n? So n is 1200, final one is 1200 rpm. So you have 1200 divided by 60 because I want to convert it to rps, minus you have n naught which is 360. So 360 divided by 60, okay, and divided by time is 14 seconds. Okay, so what we can do is we can take this 60 common and move it to the denominator, and then this 14 can be divided by 2, so that's 7. So you have pi multiplied by 1200 minus 360 divided by 60 times 7. So how much is this? 1200 minus 360, okay, 900, 840, right, 840. So therefore alpha is equal to 840 divided by 60 times 7. So I guess this is 422, right, 2 pi. Okay, so this is the answer, option B. Okay, good. Let's see next one. Two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB with speeds VA and VB respectively. The time period of rotation is same. Okay. The ratio of angular speed of A to that of B will be. Tell me. Yes. The ratio of angular speed of A to that of B will be. Let me read it once. Two particles A and B are moving in uniform circular motion in concentric circles of radii RA and RB. So, radius is different with speeds VA and VB respectively. The time period of rotation is same. Their time period of rotation is same. The ratio of angular speeds of A to that of B will be. Anyone? Option A. Indusha is saying option A. Okay, do you agree with her? That's simple, no? Angular speed is 2 pi by t and it's given that t is same. So, if t is same, angular speed would be same, right? There is no other variable. So, t is same, omega will be same, and that's why it is 1:1. This is the answer. Right, good. Very simple question. Okay. All right. So, these things RA, RB, VA, VB, they have given to confuse you, right? But it's very simple because they say that time period is equal. Okay. At that moment itself, the angular speed is equal. All right. Let's see next one. A particle starting from rest moves in a circle of radius r. It attains a velocity v0 meters per second in nth round. Its angular acceleration will be. So, tell me. Particle starts from rest. So, what is initial angular speed? Omega naught is equal to 0, right? 0 radians per second. What is initial linear speed? So, let us call it as u. U is also equal to 0 because it is starting from rest, and it attains velocity v0 in nth round. Anyone? Okay. So, see, this velocity is tangential, right? So, velocity is increasing means there is some tangential acceleration. So, can I use this equation v0 square? Okay, Yamini is saying it's option C. So, let's check. v0 square is equal to u square, v square is equal to u square plus 2 times as. Can we use this? Okay, a will be tangential acceleration. So, 2 times at into s. Can we use this relation? We can use, right? Initial speed is 0. Okay, Selva Kumar is also saying option C. Okay, let's check. So, see, you should tell me what you are doing, right? Okay, so u square is 0, then you get from there tangential acceleration at, 2 times at into s is equal to v0 square. Therefore, at can be written as v0 square divided by 2 times s. So, now what is the distance covered? Okay, what is distance covered? in n revolutions. The distance covered would be equal to n times of 2 pi r, right? Distance covered would be equal to what? N times of 2 pi r. So we have AT equals to V naught square divided by 2 times of n into 2 pi r. Okay, so this is tangential acceleration, but you want angular acceleration. So this tangential acceleration can be written as r times alpha. So r times alpha is omega V naught square divided by 4 times n into pi r, 4n pi r, and if you just move this r on other side, then you get alpha equals to V naught square divided by 4 times pi, okay, this was nr, right, 4 times pi n r square, right. So this is very simple, and yes, it is option C, right. So this is simple. Okay, many of you solved, but I was asking what to do, right? At that time you should speak up what to do, which formula to use. All right, this is clear. Yes, let's see next one. In the given figure, A equals to 15 meters per second square. So this is A is equal to 15 meters per second square, represents the total acceleration of a particle moving in clockwise direction in circle of radius r equals to 2.5 meter at a given instant of time. The speed of the particle is, tell me. Total acceleration is given. Okay, total acceleration is sum of the centripetal acceleration and tangential acceleration, and question is, radius is also given. The question is, what is the speed of this particle at this moment? Anyone? Okay, you are solving or what? Thinking. All right, so let me tell. See, this object is moving in a circle and its total acceleration is directed like this. So the angle between the radius and total acceleration is given, right? The angle between radius and total acceleration is given. So I am just redrawing it. So angle between total acceleration and radius is given. So this angle is 30 degrees. So now you can say that there would be some centripetal acceleration, right? The centripetal acceleration is just the radial component of this acceleration. So this much is centripetal acceleration. This is AC and this is A. This angle is theta. So what's the relation between AC and A? So I can just say that AC is equal to A cos of theta, that is A cos of 30. Now it's very simple. So speed is asked. So what is centripetal acceleration? It is just V square divided by R. Okay, it is V square divided by, they have taken capital R, so I will also take capital R. So that is equal to a cos of 30. What is cos of 30? Sin 30 is 1 by 2.
3 by 2.
Root 3 by 2. Yeah, root 3 by 2. So then you want v square, sorry, you want v, so move r on other side. So v square is just equal to a times r multiplied by root 3 by 2, and a is 15, r is 2.5, 2.5 times you have root 3 by 2. Okay, so then you have 15 times 2.5, so 15 times 2 is 30, 30 and 2.5, so 37, 37.5, 37.5, right, 37.5, and then you have multiplied by root 3 by 2. Okay, so root 3 is 1.732. So you have v square equals to 37.5 times 1.732 divided by 2. That is 37.5 times 1.732 divided by 2 would be near about 0.8 something, 0. Let's take 85. 85, no, it won't be 85, 865. This thing will be something like that, 0.865. Okay, so this thing will be little less than, what are the options? 4.5, 5, 5.7, 6.2. So I guess this thing will be little less than 36. Okay, but of course it will be greater than 25. So I think it would be option C, right? Okay, now they have given difficult values, not that difficult, but some calculation, and I am just guessing it. So tell me, what do you think? Is that correct, or is 6.2? I don't think 6.2 will be correct, because this thing would be lesser than 36. Yes. Okay, so check that whether it's correct or not. Tell me.
Correct, sir.
Correct. Okay, good. Then now the method is clear, this thing is clear, that thing is just calculation, and we hope it won't come in NEET. Okay, but this thing is clear, how to go given the acceleration, total acceleration to centripetal acceleration. Just take a cos theta, that's it. Okay, so that part is simple, right? Okay, let's see next one. A particle moves in a circle of radius 5 centimeters with constant speed, and time period is this much, 0.2 pi seconds. The acceleration of the particle is, so this one is very, very simple. So acceleration is, AC is just r omega square, okay, and r is 5 centimeters, is 5 into 10 raised to minus 2. You got the answer, very good. So omega is 2 pi divided by t, right? So omega is 2 pi divided by time period is 0.2 pi, that pi and pi gets cancelled, so this is 10, good. So omega is 10, so omega square is 10 square, yeah, so answer is 5 meters per second square. Very good, very simple question, right? There is nothing in this one. Let's see next one. A stone tied to the end of a string of 1 meter long is whirled in a horizontal circle with constant speed. If the stone makes 22 revolutions in 44 seconds, what is the magnitude and direction of acceleration of stone. Tell me. 22 revolutions in 44 seconds. So first of all, what is the time period? Two seconds, right? 22 revolutions in 44 seconds. Okay. How will you find time period? It is time taken divided by number of revolutions. Number of revolutions, right? So this is just time taken divided by number of revolutions. So 44 divided by 22. Okay, so that's 2 seconds. So that's fine. But then what is the question? What is the acceleration? So again, you can find out acceleration. So it is just r omega square. AC is r omega square. That is 1 meter multiplied by 2 pi by t. So 2 pi by 2, right? 2 pi by t square. T is 2, means it is just pi square. You got pi square, and it is directed along radius and towards the center. So option A is the answer, right? Okay, this one was very simple, right? Okay, everyone. Okay, you might get bored of these questions because they are very simple, right? But they are asked. Okay, two particles having mass m, and this is C, this one is, then the ratio of angular velocity will be, two particles having mass m and m are moving in a circular path. Okay, that question was different. In a circular path having radius r and r, capital R and small r, if the time period are same, then the ratio of angular velocity will be. So now whatever is the mass, whatever velocity is given, if time periods are same, yeah, then ratio of angular velocity is 1, right? Don't need to think about what is their velocity, okay, what is the radius, etc. Time period is same, means angular velocity is equal. Okay, so kind of I can say repeated question, slightly different, but then in both of the questions they are saying the period is same, right? Okay, that's very simple. Then is it the same question? Two racing cars of masses m1 and m2 are moving in circles of radius r1 and r2 respectively. Their speeds are such that each makes complete circle in same time t. Okay, so the ratio of angular speeds of first to second car is 1:1. Yeah, good, Nikita, option C. So this question I don't know, I have just taken till 1999, I guess. Yeah, so till 1999. So this question appeared first, then it might have come before also, I don't know, but then from that time, okay, in the questions that I have selected, okay, limited selection, in that too there are 3 occurrences of same question, right? Okay, they are just changing the concept, context. Two particles, here there are 2 cars in 2 bodies, something like that, masses are given, radius is given, so this one got repeated. Anyways, let's see next one. An electron is moving in a circle of radius 2 meters with speed of 4 meters per second square. Find the acceleration of electron. So tell me, which formula will you use here? Which formula will you use? V square by r, right? Alright, so it is just 4 square divided by 2, and what's that? 16 by 2, 8 meters per second squared. Okay, so it was asked in AIMS sometime, right? So very simple question. Okay, if length of seconds hand of a clock is 10 centimeter, the speed of its tip is nearly. Tell me, how will you solve this one? Length of seconds hand of a clock is given. Okay, what is the speed of its tip? Yes, V just equal to 2 pi r divided by t. And what is time period of seconds hand of a clock? Time period is, okay, you are saying speed is 1, let's check. So it's 2 pi r, so 2 times 3.14 multiplied by r is 10 centimeter, that is 10 into 10 raised to minus 2 in meters, divided by time period is 60. Alright, so then this thing is 10 into 10 raised to minus 2, this thing will be 10 raised to minus 1, 10 raised to minus 1, right? Yes, 10 to the power minus 1, then this thing is, oh, they are asking in centimeters per second, so we don't need to change this. I thought in meters per second, centimeters per second. Then this thing will be 3 times 2 nearly, okay, so 6 times 10, yeah, nearly 1, correct. So answer is nearly equal to 1, okay, so that is option E. This is from Kerala CE, okay, and there are 5 options per question. So what do you think, which exam would be more difficult, NEET or this thing? If difficulty level of questions is same, but number of options are more in this one. If number of options is more, that is more difficult, or number of options is less, that is more difficult. More options, right? Yeah, more options would be more difficult. If there are 2 options only, then even if you just tick on 50% of questions, if you tick on all questions, okay, and you don't see anything, okay, either it's A or B, then probability is that half of your answers will be correct, right? Anyways, let's see next one. A particle moves along a circle of radius 20 by pi with constant tangential acceleration. If the velocity of particle is 80 meters per second at the end of second revolution after motion has begun, the tangential acceleration is tell me. So velocity is 80 meters per second at the end of second revolution. So you have this thing v square is equal to, does it start from rest? Particle moves along circumference. If velocity of particle is 80 meters per second at the end of second revolution after the motion has begun, okay, so it starts from rest, right? So v square is equal to, you can drop u square, it is just equal to 2 times 80 into s, okay, and you want tangential acceleration only, so 80 is just equal to what? V square divided by 2 times s. in second revolution, what would be the displacement? Not the displacement, distance covered you can say. Okay, it's 2 times 2 pi r, right, because this is second revolution, so it's 2 times 2 pi r. For n revolutions it will be n times 2 pi r. And how much is this? Speed is 80, so we have 80 square, or here I will just keep it v square, and then you have 80 equals to v square is 80 square divided by 2 times 2 times 2 is 8 times pi multiplied by 20 by pi. So this thing will get cancelled out, okay, and this thing can be written as 80 times 80. So 80 by 8 is 10, 80 by 20 is what? 4, 4 times 10 is 40. So answer is 40 meters per second squared. Okay, so that is another simple question, right? This one is clear? Yes, no? Okay, good. Let's see next one. A body moving along circular path of radius r with velocity v has centripetal acceleration a. If its velocity made equal to 2v, then its centripetal acceleration is. Okay, this is another variant of a question. So this is straightforward, right? Centripetal acceleration is equal to v square by r. If you don't change radius, velocity is made twice, then what will happen to the acceleration? It will become 4 times, no? Yes, no? Yeah, so it's option A. Good. So it will become 4 times. Right, velocity is made twice, acceleration is acceleration will just become 4 times. Okay. All right, let's see next one. What is the angular velocity of Earth? So you can very easily find it out. What is the angular velocity of Earth? So it is 2 pi divided by t. Tell me, what will be time period? Is it the time period of the revolution of Earth around Sun, or it's the time period of rotation? Yeah, 24 hours. Okay, it's the time period of rotation of Earth, right? So then it's 2 pi divided by 24 hours. So that is 2 pi divided by, you need to convert that 24 hours to seconds. So how many seconds? 24 multiplied by 3600. Then you will need to multiply that out. So it is 2 pi divided by 24. This is not correct. Okay, 3600 is also not correct. Yeah, so it will be option A. Okay. So this is simple, right? Okay. All right, let's see next one. A particle is moving with constant speed v in a circle. What is the magnitude of average velocity after half rotation? Tell me, what is the magnitude of average velocity after half rotation? A particle is moving with a constant speed v in a circle. What is magnitude of average velocity after half rotation, half revolution? Yes, anyone? Option B, 2v divided by pi, you are saying? Okay, let's check. So see, the particle moves from, let's say, A to B. So it will go to the diametrically opposite point. Okay, so this is half revolution. So therefore, you will have average velocity V average is just equal to what? Displacement divided by time. So what time will it take to go to the other side, meaning to complete the half revolution? Time taken would be just equal to t by 2, right? So it is displacement divided by time. Displacement, you can say it's 2r and time taken is t by 2. You can move that 2 in the numerator. So what do you get? You get 2 times of 2, that is 4r by t. And then you have v is equal to 2 pi r divided by t, right? Because all of the answers are given in terms of v. So what we can do is we can write this thing as 2 pi r. I can write this as 2 times 2 pi r upon t. So what I have done is I have written this 4 as 2 times 2, but I have 2r only. Okay, then you need to multiply by pi. So you should divide by pi also. So that is 2 by pi multiplied by 2 pi r by t. So that is v. Okay, so answer is, yeah, so it's correct, 2v divided by pi. So it's option B. So that is, yeah, it is also simple, right? So Yamini solved this. Good. This is clear? Yes, no? All right, good. Then let's see next one. A particle is moving uniformly in a circular path of radius r. When it moves through an angular displacement theta, then the magnitude of corresponding linear displacement will be. Okay, a particle is moving uniformly in a circular path of radius r. When it moves through an angular displacement theta, the magnitude of corresponding linear displacement will be. This is the question. So this is a slightly different question. Let me explain this. So see, your object is moving, suppose, from again A to B. Okay, and angular displacement is theta. So what is the linear displacement? So see here, linear displacement would be this much, right? So that is delta r, right? So this length is r, this length is r, okay, and this thing is delta r, this thing is delta r. This is the linear displacement. So now if you see all of the options, there is theta by 2, theta by 2, theta by 2 in all of the options. Okay, so this linear displacement delta r has something to do with theta by 2, right? So what we can do is we can just draw a bisector of this angle. So it will bisect it in two halves, theta by 2 and theta by 2. Okay, so let's suppose this point is O and this point is C, right? So then now if you take the relation between r and this delta r, or r and you can say delta r by 2, what will be the relation? You can take this angle, this is theta by 2, right? see the angle is theta by 2, this angle is theta by 2. Let me use this color, theta by 2, sorry, theta by 2. Okay, so if you take sine of theta by 2, if you take sine theta by 2, what do you get? It's equal to the opposite side is BC, okay, or you can say delta R divided by 2. So delta R divided by 2 divided by the hypotenuse. How much is hypotenuse? It's R. So delta R by 2 upon R, right? Then you can take that 2 in the denominator and then you get 2R, you can move it on other side. So here you get delta R is equal to 2R multiplied by sine theta by 2, right? You will get 2R multiplied by sine theta by 2. This thing is clear? Yes, no? Everyone? Okay, good. So now this question is not asked in NEET, but it is asked in different exams which have similar difficulty level as that of NEET. Okay, so that's why I have taken it. So see, displacement is 2R sine theta by 2, so it is option D, right? Okay, so now you can just remember this thing, and this thing will be helpful for us also. For an example, suppose object moves from A to B, okay, just an example. And the angle covered or angular displacement is 90 degrees. Let's say angular displacement is 90 degrees. So what would be the linear displacement? So theta is equal to 90 degrees. What would be linear displacement? Delta R just equal to 2R multiplied by sine of theta by 2. Sine of theta by 2 is 45 degrees. Okay, so that's 2R multiplied by sine 45 is 1 by root 2. So then you get root 2 times R, right? What do you get? Root 2 times R. Okay, so now this kind of any angle could be given. Okay, 90 degrees is a possibility, right? Because they have they take 90 degrees, 180 degrees, something like that, but they can give you 270 degrees or 120 degrees, whatever. So even if it is 120 degrees, now based upon whatever we learned, we can find out how much is the linear displacement. Okay, we can just resolve it, etc., but we don't need to do all those things. We can simply remember this formula, that linear displacement is just equal to 2R times sine theta by 2. Okay, linear displacement is just equal to 2R times sine theta by 2. So if angle is 120 degrees, just take sine of 60. Okay, so what would be linear displacement? 2R multiplied by sine of 60. This thing is clear? Yes, no? Okay, so just remember this thing as a fact, as a trick, you can say. Okay, good. All right, so just remember this thing because they can ask about the linear displacement. Okay, let's see next one. A ball is moving in circular path of radius 5 meter. The tangential acceleration at any instant is 10 meters per second squared, and net acceleration makes an angle of 30 degrees. This is similar to what we had seen, right? With centripetal acceleration, then instantaneous speed is. Okay, tell me. So what's given? Tangential acceleration is there. Tangential acceleration at any instant is 10 meters per second squared. So let's suppose this is tangential acceleration and this is 10 meters per second squared, and something else also is given, that net acceleration makes an angle of 30 degree. So net acceleration something like this, let's say, right? Let me reduce tangential because I want this angle to be 30 degrees. Okay, so this is net acceleration a bar, this is tangential acceleration, and this is centripetal acceleration. Okay, what is given? It makes an angle of 30 degrees with the centripetal acceleration. So this is 30 degrees. Then the instantaneous speed is, tell me. It is along the tangent. Yeah, now it's good. No, it's same. All right. So assume that it's a tangent. Okay, it's vertical. Tell me. Till that time, I will try once more. Okay, this one is not better. Yeah, good. Anyone? Did somebody comment? Okay, so see, you want centripetal acceleration and this acceleration, angle between them is given. Option B. Yamini is saying option B. Let's check. So this angle is given, right? Then now see, you can just take tan of theta here. Okay, it is equal to this opposite side, which is tangential acceleration divided by centripetal acceleration, right? So tan of theta is tangential acceleration divided by centripetal acceleration. And you want speed, no? So it is just v square by r. Centripetal acceleration is v square by r. So that is equal to 80 divided by tan theta. That is equal to, how much is this acceleration? 10 divided by tan of theta is 30 degrees. Tan of 30. What is tan of 30? 1 by root 3, right? So therefore it will be 1 by root 3 in denominator. So 10 root 3 in the numerator, and that is your v square by r. Then you have r equals to 5. So move that on other side. So v square is equal to 10 times of root 3, that is 1.732 times 5. Okay, so this thing is 50. 50 times 1.73. So I will just take 173 divided by 2. Okay, so I have multiplied by 100 and dividing by 2.
We have 50 by root 3 option, sir.
50 by root 3?
Option A, sir.
50 by root 3. 50 root 3 you are saying. Okay, 50 root 3, that is v square, no? We want v. Right, no problem. So you have 173 divided by 2. So that will be 170. So that's 85, 85, 86, 86.5. So 86.5. So this is, yeah, Yamini said option B, no? Yeah, correct. It's option B. 9.3 meters per second. Good. Because 9 square is 81. Okay, so this will be little bit more than that. Right? So you solved this way, Yamini, or did something else?
I took v sine theta equals to tangential acceleration.
V sine theta. A sine theta.
A sine theta equals to tangent.
Yeah, A sine theta is equal to tangential acceleration and A cos theta equals to centripetal, like that.
Yes, sir.
Okay. Yeah, it's same thing. you can save little bit of time if you just take the ratio, right? But whatever clicks, right, while solving the numericals. Okay, very good. Let's see next one. The position vector of a particle is this thing. Okay, the velocity vector of the particle is, tell me, parallel to position vector, perpendicular to position vector, directed towards the origin, directed away from the origin. Tell me. So option B, very good, it's perpendicular to position vector. So see, now here we are discussing circular motion, and here we know that position vector and velocity vector, they are perpendicular to each other. But if this thing is given, this thing comes in the exam, right, and then you should recall that this is position vector of a particle. It's given nowhere, right? It is position vector of a particle performing uniform circular motion. You should remember that. Okay, so that's why we took that calculus method. Okay, so you should remember this. This is the position vector of a particle performing uniform circular motion, and if it is uniform circular motion, then radius vector and the velocity, they are perpendicular to each other, right, because velocity is along the tangent. Oh, I zoomed it and perpendicular became parallel. Anyways, this is clear? Yes, no? Good. All right, let's see next one. So a particle moves so that its position vector is given by this thing. So now they are calling x cap to I cap. Okay, as we discussed, the unit vectors along x, y, z axis, they can be written as I cap, j cap, k cap. They can be also written as x cap, y cap and z cap. Okay, there is no problem. Okay, where omega is constant. This is from NEET, I guess 2021, I guess. Okay, which of the following is true? Velocity and acceleration both are parallel to r bar. Velocity is perpendicular to r bar and acceleration is directed towards the origin. Okay, is this thing correct? Yes, no? Velocity is perpendicular to r bar and acceleration is towards the origin. Origin means towards the center. This one is correct? Yes, no? Yes, this one is correct, right? Yeah, so this is very simple. Okay, so again, it's not written that particle is performing circular motion, but given this, it should click to us that particle is performing circular motion. Okay, so please remember this position vector. All right, let's see next one. Radius of a circle, the period of revolution, initial position and the sense of the revolution are indicated as shown in this figure. Y projection of radius vector of rotating particle P is, Y projection means Y component. Tell me, anyone? Okay, see, you have this particle which is revolving in the clockwise sense, right? It's given here, it's revolving in clockwise sense. So suppose this is the position vector. Now which angle will be theta? This angle or this angle? This angle will be theta, right? This angle is equal to theta, and then you can find out Y projection or Y component. So what will be Y? If this is r bar, then Y is equal to r cos theta, right? Okay, Y is just equal to r cos theta. That is, Y is equal to r cos of, what is theta? Omega t. Okay, let me write it here. Y is equal to r cos of omega t. And what's given there? Radius is given. See, the radius is given 3 meters. What else is given? Time period is given 4 seconds. That means you need to write it in terms of time period. Okay, so radius is 3, so it is 3 cos of, what is omega? Omega is 2 pi by capital T. Okay, and what is capital T? Capital T is 4 seconds. So 3 cos of 2 pi divided by 4 T. So what's that? 2 by 4 means pi by 2, right? 1 by 2 times pi is pi by 2. So it is 3 cos of pi by 2t. So this is the answer. Okay, so it is option C. Right? Got it? Yes, no? Okay, good. So see, this all comes from that calculus method. Okay, so sometimes they can ask about what is the velocity. They asked about what is the position vector. Here y component, they are asking about the y component. So sometimes they ask about position vector, whether the velocity is perpendicular or not, right? So you need to remember all that. Okay, let's see next one. Wheel is rotating at 900 rpm about its axis. When power is cut off, it comes to rest in 1 minute. This is simple one. The angular retardation is, so I will skip this one, or I can just say that when it comes to rest, what will be omega? Omega will be 0. What is omega naught? Omega naught is, you have n naught is given. Okay, it is equal to 900 rpm. So it is 900 divided by 60, right? So that is 15 rps. Okay, so what is alpha? Alpha is omega minus omega naught divided by t. Just put the values. So omega is, this is 0 minus 2 pi multiplied by n is 15 divided by 1 minute is 60 seconds. So actually we have solved it. Okay, so 2 pi by 4 is pi by 2. So the answer is minus pi by 2. This much is acceleration. So the magnitude of retardation, retardation means negative acceleration. Okay, angular retardation is pi by 2. That's the answer, right? So this is very simple. Yes, Selva Kumar? Good.
Yes, sir.
Good. Let's see next one. So let me just check whether it's worth solving. Okay, let's solve this one. The motor of an engine is rotating about its axis with an angular velocity of 100 revolutions per minute. It comes to rest 15 seconds after being switched off. Okay, comes to rest 15 seconds after being switched off. Then what is the number of revolutions made by it before coming to rest? Tell me. How will you solve this? So one way to solve is, see, theta is equal to omega naught t plus half of alpha times t square. So here you will need to find out alpha, here you will need to find out omega naught, right? How can you find out alpha? So alpha is just omega minus omega naught divided by t. You can find it out. Okay, omega is given, angular velocity is given in terms of revolutions per minute. So you can find out omega naught, which will be 2 pi n naught. So that is one way. And what will be the angle? Angle covered in, what is the number of revolutions? Okay, so we'll get the angle. So in one revolution, the angle covered is 2 pi. For n revolutions, you can say that angle theta is equal to what? N times of 2 pi. Right? Yes, no? Is this thing clear? Everyone? Okay, so this is one way to solve it, but then we can do a better job. Right? Yeah. So see, what we can do is we can find out average frequency. What is average frequency? Final frequency plus initial frequency divided by 2. That's it. So final frequency is 0. What is initial? Initial is 100 revolutions per minute. That means 100 by 60 revolutions per second divided by 2. Okay. So that is 10 by 6 means 5 by 3. So this is 5 by 6. That 2 is there in the denominator. This is 5 by 6. Okay. This is revolutions per second. And how many seconds are there? How long does it revolve before stopping? 15 seconds. So that is given. Okay. So we can just say so n average is just equal to, or not n average, total number of revolutions is just equal to average frequency, n average multiplied by time, because what will be average frequency? Total number of revolutions divided by time. So what will be total number of revolutions? It is just average frequency multiplied by time. So let's call it n. So n is just equal to average frequency we calculated, it's 5 by 6 times 15. So that is 15 by 6. I can divide by 3. So that's 5 times 5 divided by 2. 25 by 2. 25 by 2 is 12.5. Right? 12.5 revolutions. So this is how we can solve it quickly. Okay, this thing will take time, considerable time. You can try it. This thing will take time, this method. Okay, so this second method is clear? Yes, no? Everyone? So the answer is option A. Right? Good. Then now let me check the questions. Okay, this I will leave. Okay, let's see this one. A particle is moving in a circle of radius r with constant speed v. The change in velocity after the particle has travelled a distance equal to 1/8 of the circumference of circle. Tell me, change in velocity after the particle has travelled distance equal to 1/8 of the circumference of circle. So if it travels 1/4, this thing will be 1/4. So 1/4, right? So for 1/8, how much will be the angle? It's 45 degrees. Okay, or you can say it's pi by 4. Theta is equal to pi by 4. So what will be change in velocity? Tell me. Speed is constant. Okay, see, you have this relation. If you remember, we just saw it. Delta r is equal to what? 2 times of r multiplied by sine of theta by 2. We have this relation, right? So then what will be delta v? We saw one radius triangle and one velocity triangle. They are similar to each other. So delta v in similar fashion can be written as 2 times of v sine of theta by 2. Okay, This thing is clear? Yes, no? Everyone? Okay, good. So then you can just say that it is 2 times of V sine of theta by 2. But what is theta by 2? So here there is little problem. Sine of theta by 2. What is theta? What is theta? Theta is pi by 4. Okay. So what will be theta by 2? It's pi by 8. Right? It is pi by 8. Okay. So then this angle would be 22.5 degrees. Okay. This is theta is equal to 45 degrees. So half of that is 22.5 degrees. So how can you find out sine of that? Can you find out sine of that? Anyone? So see here, I will tell you 2 ways. First is the intuitive way. So just look at the options. Can it be 0? Of course not. Sine 0 is 0. Sine of 22.5 degrees is not 0. Okay, 2V. Sine of this is 22.5 degrees. Okay. So sine of 22.5 is not 0. Then look at the other options. So for which angle sine is 0.5? For which angle? This is, of course, for which angle it is 0.5? It's 30 degrees, right? For 30 degrees it is 0.5. Okay. So sine is 0.5. This thing is 0.5. Then, okay, if the angle is 30 degrees, then this thing will be 0.5. 0.5 multiplied by 2. How much will you get if, if the angle is 30 degrees? 0.5 times 2 is 1. So your answer would be V. So if this angle is 30 degrees, your answer would be equal to what? V. But then if it is little bit less than that, what will be your answer? So your answer should be this thing. This thing is clear? Yes, no? Okay, everyone. Okay, good. And then now if you insist on solving it, so there is a way. Can you tell me what's the way? Okay, so see, we had seen this formula, 1 minus cos of 2 theta is 2 sine square theta, right? Similarly, I can say 1 minus cos of theta is equal to 2 sine square theta by 2. Take that 2 on other side. So sine square theta by 2 is equal to 1 minus cos of theta divided by 2. Okay. So now take theta equal to 45 degrees. So your theta by 2 will be equal to what? 22.5 degrees, right? So you have sine of 22.5. Sine of 22.5 degree squared is equal to 1 minus cos of 45 degrees divided by 2. And this thing is 1 minus cos 45 is 1 by root 2 divided by 2, right? Then this thing will be root 2 minus 1, so that is 0.41. Okay, root 2 minus 1 divided by, it's 2 root 2. Okay, so this is lengthy. Okay, and then this is equal to 0.4 divided by root 2 times 2. So you can say it's 0.2 divided by root 2. Okay, or you can say it is, don't know, 2 times 10 0.1 divided by root 2. So again it will be root 2 times 0.1, so 1.41, 0.141, right? So that is sine of 22.5. Then no, it is square of that. Then find out its square root and then you will get the value. okay, if my calculation, this thing is correct. But this is how you can solve it. This thing is clear? Yes, no? Okay, but we don't have this much time, right? We don't have this much time in NEET. So if there is a question like this, what we can do is we can just look at the options and we can think, okay, sine of 30 is 0.5. If I take 30 in place of 22.5, answer should be closer to that. Okay, the value of sine goes on increasing from 0 to 90 degrees. Okay, sine 0 is 0, right? Sine 90 is 1. So it goes on increasing gradually. So if I take 30 degrees, answer should be closer to that, but little bit less than that. Sine of 30 is 0.5. 0.5 times 2 is 1. So that's why for 30 it is V. For 22.5, the answer should be little bit less than V. Not very less, but little bit less than V. So that's why I am taking this. Okay, that is clear, right? Good. So now again, this is based on the same trick, right? Delta R is equal to 2R sine of theta by 2. So just remember this formula and these kind of questions will be solved then. Okay.